Hello and welcome to this video on data visualization using Python. In this course, you'll explore the art of transforming raw data into meaningful insights using Python. Whether you're a data enthusiast, analyst, or developer, this hands-on course will guide you step by step in mastering powerful visualization libraries like Matplotlib and Seaborn. You will experience a unique blend of a pre-recorded live virtual classroom session designed to give you the feel of a live learning environment while allowing you to progress at your own pace. The video is hands-on, meaning the practical approach ensures that you not only understand the theory but also apply it in real-world scenarios. By the end of the course, you will have a strong grasp on data visualization in Python, making you job-ready and giving you tangible work to showcase to potential employers. So, are you ready to transform data into beautiful visuals? Let's dive in. But before that, make sure to subscribe and hit the notification bell to stay updated with the latest videos. So today what we are learning is we are going to look at a visualization library in Python called Matplotlib, and specifically within Matplotlib there is a submodule called PyPlot. Okay, this thing PyPlot, PyPlot, and that is the primary module or package that we will be using to create visualizations for various analysis purposes. Okay, now typically we import it with the name PLT. So just like NumPy for NP for NumPy, PD for pandas, we will import matplotlib.pyplot as PLT. Okay. Now just want to show one more thing. There is another way to write these import statements. So from matplotlib import pyplot as PLT. Even this will work. Okay, same thing. So this is a slightly different way of importing this, right? This is a module within this package. So from matplotlib package import pyplot as PLT. Just it's the same thing, but there are two ways. So what we'll do, first part we'll load this car prices data. We are already familiar with this. Okay. Now you will notice that it's called car prices data viz. It is different from car prices in the sense that it has all the same rows and all, but we will see what is the difference. Okay. So I just read in the description. We already saw this and we already know this data, car ID, car name, door number, car body. We did a bit of preliminary analysis and those kinds of things when we did pandas on this data, and we know this description df. Okay, this gives you what is symboling, what is door number, what is engine location, and it gives you all the features. Pretty big, right? Read it when you have the time, I would say. And we also remember df info. Whenever I want to know something about my data frame, what would I do? I would use df info. Correct. So df info tells me interesting things. It says that my car prices data has 205 entries from 0 to 204, and it says that there are 21 columns. Okay. It also gives me the data types. We know all this. But the interesting thing is this. So when you see here non-null count, right, each of this is a column, each of this is feature. So if my data has 205 rows, then I expect each feature to have 205 non-null values. But there are only some rows which have 205 non-null values, right? The other rows seem to be having 204, 191, 196. So what is going on here? So clearly there is some missing data. Okay. So in this data set, missing data analysis and data cleaning is something that we'll explore in much more detail later when we do data cleaning, processing, EDA, those kinds of things. But it's better to start understanding what's going on, right? So that's something we need to do, right? We need to handle missing data. Now before we do that, if you remember convert d types, it converts all the features into the most suitable data type. So we can even do that, and if I do that, I'm getting int here, I'm getting string here, float here. Okay, sure, not bad. So one thing to keep in mind, for example, is we are not using the symboling feature. I think in this analysis probably we are not using, but if you go to the data description, it says symboling is actually a categorical risk rating, and if you see the symboling feature, it says 3, 1, 2, -1. Basically this is some kind of risk rate, risk of the car, and the dataset providers have labeled it as a categorical variable. But if you do df convert d types, and in fact if you don't do that, still it is float. Without converting d types, symboling is still float. If you do convert d types, now it becomes int. Now that means pandas thinks why df is not defined. Are you reading with the correct name? Car prices data viz.csv. Please go back to the folder. I'll give you the folder link again. Please check the folder. Don't change your data name. download this data again. Okay, I think the older data was there in that, so maybe that's why the problem is. Okay, so the data we are using is car prices dataviz.csv. Check it and let me know, please. Others, are we getting this issue or it's running? Okay. Okay, Pratim and Sauradeep, please re-download. Okay, re-download and run it. And check the name of the data. Even in the folder, the data name is car prices underscore data underscore viz. Okay, here also read statement. Check the data. And if you're using Colab, of course, you need to replace the file if it's the wrong file. All right. Okay, please do that. Right. So how do we deal with these missing values? Right. That's what we're talking about. Anyway, so symboling we are not using, but I just wanted to show that it's possible for convert D types to go wrong. Right. If you remember last time we were saying there are some cases where you should be careful. Correct. So according to the data provider, symboling is categorical, but according to pandas, symboling is int64. Right. So this is something that you may need to look out for. Anyway, we are not using this in this session, but just wanted to say that such things do happen. Okay, so let's look at missing values in numerical column. So for example, if you see here wheelbase, it says 191 non-null float 64. Okay, so if I just check wheelbase, it's like I think the length of the wheel or diameter of the wheel, something like. Okay, and of course I can use .info on a series. We remember that. So here it says 205 entries with 191 non-null. So suppose I want to replace the missing values here. It has obviously 191 205 minus 191, which is what, 14 missing values. Okay, so I want to replace missing values, means it's not there. Okay, so those values are not there. So for example, you can actually do df wheels dot is null, and it will give you false true false true false true false true, right? So if you take this and then do like index the series, right, it will give you these values. So row number 6, 12, 29, 30, 32, 53, 63, 76. I hope we remember all this, right? So is null is the new command that you're seeing. It actually returns true or false, whether there's a missing value in that entry or not. Okay, I am applying is null on the series df wheelbase. Okay, indexing my series based on that. Okay, so you can see 6, 12, 29, these are the missing values. So one way to deal with the missing values is you replace it with some value, typically mean or median or something like that. It's not recommended, but I'm showing you that it's possible. If you have strong reason to replace that, then you can do that. So what we can do is we can calculate the median value of this wheelbase. So df wheelbase dot median. Okay, so df wheelbase dot median, and here I have this median value. What is that? It is 97. Okay, so median of all these values is 97. So wherever these NA are there, you can use a corresponding method called fill NA. Okay, so is null gives you true or false, right, whether there is a missing value in that entry or not. Fill NA fills that value with some value. So I want to fill the values in this column df wheelbase, right, this series. I want to do it in place. Okay, so df wheelbase dot fill NA, fill it with what? Fill it with median value 97. Okay, in place equal to true. So now if I do fill NA and check info, you will see 205 entries here, 205 non-null entries here. So what you effectively done is you found out the indices where the value is missing for the wheelbase feature. Then you decided that you want to fill it with the median of the remaining values. Okay, so you took that value and then you filled the same value for each of these, right? So next, if I just do df wheelbase and suppose one of these 76, the value that you filled is 97. Suppose I take 159, right? These are obviously the index of the series, yeah, 159 and all that. So here also I've replaced with 97. Okay, so let's go ahead with the median for this one. All right, great. Next, this is for a numerical, right? Typically for numerical things, you may want to fill with a median or fill with a mean, or if you have domain knowledge, then you should use domain knowledge. What can you do for categoricals? So similar thing, right? So suppose I take df door number. Okay, we remember this feature, don't we? It is interestingly, it's a string feature. Okay, now if I do df door number dot info, all right, 205 entries, 196 non-null. So again, it's missing values. So what you can do is you can actually get the mode, and we all remember this df door number dot mode, right? And what you need to understand here is that, and if we did practice last time, in pandas, the result of dot mode, so df door number dot mode, right, is a series. Okay, we all know that this is a series, right? So if you want the value from the series, then you have to pull out the value, and here the value is the string 4. This is the value. So mode value is a series, so I need the value 4. Okay, so what I'm doing is mode value dot iloc 0. You can also just do mode value 0, iloc, loc, all of it will work, right? Because this is integer index. So iloc 0, this gives you the value 4. Now again, similar method, you just take the column that you have these missing values, right? And then fill NA, and here I'm using mode value ILOC 0, this one, 4. So wherever it is missing, I'm using 4. Why? Because it's the mode. So for categorical variable, again, this is, obviously subject to debate, right? Whenever you do such filling the missing value and treating missing value, all that, you should, it depends on your analysis, depends on what you think is right, okay, in your business problem, right? So here I'm just showing that some of the methods exist. This will be dealt in more detail a bit later. So anyway, since this 4 is the most prevalent type of car, 4 doors, so let me go ahead and assume that whichever is missing may be probability higher that they are also 4 doors. So I'm filling the missing values with that. Okay, and as you can check, 205, 205. All right. So if you check now, after these two exercises, right, one is wheelbase and one is door number. If you check df info, now again you should check 205, and now I see 204, 204, 205, 205, 205, 204. So if you look at this number, what it is trying to tell you, just see 204, 204, 205, 205, 205, and so on. What is it trying to tell you? These are features, right? Each of this is feature column. So there is a very high likelihood that whatever these 1111 missing values, so you see car ID is missing one value, symboling is missing one value, engine location missing one value, car width is missing one value. So there's very high likelihood that these single missing values are all part of the same row. High likelihood they may all be part of the same row. So previously we saw example of corrupt columns, right? So now what we are looking at, after clearing those columns, what we are looking at now is example of corrupted row. Maybe I shouldn't say 100% from this I know it's a row. It may be up and down, but more often than not, when you see numbers like this, that means one row or two rows or something is corrupt. Okay, so here again we can use isnull. So now I showed you isnull on series, so now I'll show you isnull on the data frame. So if I do df.isnull separately, now you see what is isnull doing? It is actually giving you true and false for each location in your data frame. Is the data missing or not? Okay, and if I want to find the row index, right, or the column index, if there are any missing values, there's a short method which is what I've shown here. I can just do dot any. This just means is any of my data missing, okay, in the object. So what is the object? This one, df.isnull is the object. So the data frame you're looking at, this is the object. On this object, dot any means if any of this is true, then it will give that row. So to specify that, we do axis equal to 1, okay, and as you can see here, it will collapse those columns. Okay, axis equal to 1 means collapse, like any of the columns. Think of it, we remember numpy, right? So axis equal to 1 means and we know 1 is column, by the way, right? Dimension 0 is the row, dimension 1 is the column. So when I do dot any axis equal to 1, it's actually checking all the columns for one row and asking the question, is anything true here? If anything is true, return. So now if you see false, 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 and there will be some true inside this. Okay, there will be some true inside. So this thing, if I can use this to get the number of missing values. Now, one thing that you it's something to understand is, for example, if I say false plus true, the answer is 1. So Python basically treats false as 0 and true as 1. Okay, so if I do false plus true, it gives me 2. Okay, notice. So Python is actually treating false, the logical value called false is treated as 0, and the logical value called true is treated as 1. Okay, now having that information, what can I do with this? If I just do dot sum, then I'm going to get the number of true, isn't it? Because true is equal to 1. So what did I do? df.isnull dot any, collapse all the column, right? So now I'm getting rows in which at least one true. At least one true. What is true? Is null. Okay, what is true? Is null. So here, if there is a single true somewhere, dot any will say true. Okay, is any of this true? That's all. So if you want to explore this further, you should also look at dot all. Okay, so the other opposite end is dot all. this one. Okay, you can actually go and check .any and .all. So these are methods which quickly allow to check true and false in large, vectorized data. Anyway, so now that I have these rows, now where will it be true? Wherever any one column is true, it will be true, which is why it is .any. Okay, and x is equal to 1. So if I do summation of this, I will get number of rows basically where data is corrupt. Let me store this series in this variable rows with nans, and I'll just do dot sum on the series, right? So wherever it is true, we'll get true plus true plus true plus true n number of times, and it is only 1. The answer is 1. So we are confirming that there is only one row which has the missing values. So now we can get the row index, right? So IDX max, what is that going to do here? IDS max, because false is 0 and because true is 1, and because I know that there is only one row which has missing value, which means only one value inside this series, the isnl series, only one value is true, and I know that true is equal to 1. Therefore, if I do IDX max value is 1. Therefore, it will return me the index where it is 1. And 1 is meaning true. True for what? Is null. Okay. So take some time to understand this, right? I just sort of want to walk you through it. I really do believe that the more time you spend experimenting from here on out, you'll get sharper with the tools. Okay. But I think all of this is making sense. So I can use IDX max and I get the row index where it is, where there's a 1. Now, of course, IDX max is not the typical method that you want to use here. You can use dot index, right? So you just subset this based on the value and then get index. That is also something you can do, which is what is more typical. This is just, funny arithmetic. So I can just do, for example, this is false, true, false, true, false, true. What I can do, I can just do rows with nans, where rows with nans. Why did this work? Does everyone understand why this worked? I did not do equal to true. Why? Because value itself is Boolean. Okay, value of row with nans itself is Boolean. This is false, this is true, right? The value itself is Boolean. So wherever it is true, when this is true, row with nan bracket true. Okay, so it will only give me the index where it is true. You'll get the same value if you do this, exact same. But you don't need to do this because the original is, Boolean. Anyway, so here you got the index. So now you just do dot index, that's all. Okay, let's have a look at this row. Interesting, very interesting. See, car ID is NA. Okay, symboling NA. Car name is Dodge Monaco. Door number 4, car body hatchback. This probably came from our median filling or mode filling or something. Wheelbase obviously came from our median filling, right? We remember this 93.7. So this row is actually very corrupt. So now you can take a call. Do I really need this in my analysis? See, I have the car name. This 4 I filled. This 93.7 I filled. You just have one car body. You have one bore ratio. You have some peak RPM. This is not good enough data, if you're really going to do some strong analysis. So as a data analyst, as a data scientist, you will be faced with multiple cases where you have to think of which columns you're using, think of which rows you're using, how you're replacing values, how you're creating values, or are you using subject matter knowledge to go and correct the values, right? These are all questions that you have to handle. Okay, I'm just showing you some of the methods now and very brief, right? Which is why we are closing this section in half an hour, and then we'll go to the actual session, which is Matplotlib. This will be explored in more detail in EDA. Anyway, so this row is pretty bad, right? So what I can do is I can drop NA. So df.drop NA in place equal to true. Okay, drop what? Yeah. Now, one thing we need to understand here, drop NA, we are assuming that all the null values are here. So, you can quickly count the null values, right? So I can count the non-null values, or I can just do .info if this is a series. Let's see. Of course, it's a series. So I have 8 non-null and 21 entries. That means 21 minus 8, 13, right? 13 NA values inside this row, df.iloc24. Now, if I just do df.info originally, and then here I can see, how many non-null are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. All the missing values in the data frame right now are present inside the row, which is why I can safely do drop NA. Otherwise, it will drop multiple rows and multiple columns. Be careful. Typically, you want to delete the row. Okay, what you want to do here typically is delete the row, not don't, typically we will not be using drop NA, because drop NA will drop everything. It will drop row, column, wherever the NAs are there, it will drop. The only reason this is working is because my 13 missing values in the series, which series? df.iloc24, right? This series, which is my row, it has 13 null values, and my data frame also has 13 null values. So obviously they are the same. All those 13 values are in my row. Okay, otherwise you have to individually go and delete the rows. Okay, so for now we'll go ahead with this. It works, no problem. Yeah, now after all this we can say, okay, 204 entries, and here also 204, 204, 204, and now we have a data frame without any missing values. Now another thing that you want to consider when you're doing data analysis is class imbalance. This is going to pop up again and again. So suppose, for example, you take df engine location. Okay, if you remember, it was what, rear, front, something, right? And we remember value counts, don't we? So if I just do value counts, okay, rear and front. So front I have 201 cars, okay, and rear I have 3 cars. This is what we call class imbalance. Again, the question is, are you really doing any analysis if majority of your data for a single feature are the same value? Is there any analysis based on that value? And this specifically applies to categorical variables such as engine location and things like that. Okay, so again I'm repeating the question. Do we really want to use this? Does it make sense? So if I say, what is the mean price of engine location front car and what is mean price of engine location rear car? Here you use 201 cars, here you use 3 cars. Is it fair to do a comparison? In most cases, when there are very highly imbalanced columns, some of the times we have to take the decision of dropping the column. Okay, because what are you going to do with 3, right? You can get some information, but can you put faith in that? That's the question. Suppose it was 100 front, 100 rear, and then you take the mean price. You can put more confidence and faith in that analysis, right? How can you put confidence in this? So class imbalance is something that is something we have to think of. Now, when you do data analysis, these are the things that need to come out. These are the insights that need to come out, right? And later, when we do sort of advanced things like machine learning, things like that, there are ways to handle this. And even in some advanced analysis, there are ways. But first, we should try to see that and at least do some faithful analysis if we can't reckon. Okay? So here I'm doing df.drop columns equal to engine location. This does not need to be a list, but it can be a list, whatever. In place equal to true. Okay, so now this is my final data set. And I already have the cleaned version, but you guys can save it. So the way to save it is df.toCSV. I have just commented it out here. So you can just uncomment and save it. Okay. So if you do this, it will create a file inside your same folder, by the way. For Colab, it should create it in the left side, right? Where you have the files and folder section. For Jupyter, wherever your folder is, where the notebook is, that is where you will get this. Okay, just in case, I'm uploading the cleaned version into the folder also, the Google Drive folder. So let me just again give the link. So look, first I want to start off with exploring numerical variables. Okay, and scatter plot is nothing but XY axis, right? In school, when we studied X coordinate, Y coordinate, points, quadrilateral triangle, whatever, that's exactly what it is. So you have pairs of points, and you're just plotting on the X and Y axis. Okay. So suppose I want to ask the question, what is the relationship between engine size and horsepower? So before plotting, it's always a good idea to see what you're dealing with. You're dealing with integer engine size. Okay. And you're dealing with integer horsepower. Okay. So basically int versus int. Another thing to notice is that repeat values are there. So don't think that all the values will, sit separately on the graph and everything looks clean. No, obviously not, right? There are, many cars can have the same horsepower. Many cars can have the same engine size. This is what real data is going to look like. Okay. So, all right. Now, what is the relationship between engine size and horsepower? In other words, I'm asking the question, if I increase engine size, does my horsepower increase? Okay. So one nice, or if I decrease engine size, does my horsepower increase or decrease, right? So one very nice way to analyze that is the scatter plot. And if you remember, we imported matplotlib.pyplot as PLT. The command for that is plt.scatter. Now, before we get into matplotlib, I just have a disclaimer that I need to tell everyone. And I want confirmation that you are understanding what I'm saying right now. Matplotlib. So let me repeat. Pandas is to NumPy the way Seaborn is to Matplotlib. In other words, NumPy is very abstract, very structural, very mathematical. Pandas is very informative, very intuitive, very human friendly. Do we all agree about NumPy Pandas? Can you please tell me if you agree? Wonderful. Great. Wonderful. Similarly, Matplotlib is structural, mathematical, and somewhat abstract, whereas Seaborn is intuitive and easy to use. The very reason for the development of Seaborn on top of Matplotlib, that's another analogy. So Pandas is the top of NumPy. Seaborn is on top of Matplotlib. Okay. The reason for development of Seaborn is this is very structural and behind. It's on the back end of your visualizations. So in today's session, we'll be seeing a lot of things. We'll do a bit of investigation into the back end and things like that. But I would say not to worry if it looks complex. Sometimes to me also Matplotlib seems quite complex. NumPy is still okay, but Matplotlib has a lot of things going on, right? Seaborn is built on top of that to make our lives easier. Again, the idea is you understand what's happening so that you know what you're using in Seaborn. Okay, so everyone understood what I said? Please put a yes, and then I'll continue. Oh, thank you. Abhishek says yes, Anusha yes, Sonal yes, wonderful. Akash, Ashi is great. Okay, so the command is plt.scatter. Okay, so as I told you, it's just x and y, nothing else. So on x you can put df engine size, which is on the x-axis. Y you can put df horse. When you execute this, you will get a scatter plot. That's all. Notice that there is an increasing trend. Higher the engine size, higher the horsepower. And obviously, a lot of things are missing, right? X-axis label is missing, y-axis label is missing, title is missing. Some dots are sticking together, not looking really nice. See these 5-6 dots. This looks like some sort of flower. It's all looking a bit weird. Okay, and also there is this interesting text output on the top, matplotlib.collections path collection. Okay, so the thing is that when you create a visualization with Matplotlib and Seaborn for that matter, you are actually outputting an object. But where is the object? You might say that this is the object. This is the rendering of the object. Okay, the object is actually there. You are showing it. So basically what I was saying was that this thing is actually an object. We'll see what this object is a bit later. But if you want to suppress this output, and typically I like to suppress this output, right? Of course, when you're doing dashboarding and all that, you may want to pass objects from here to there, right? A little bit later you will encounter that. But right now, when you're only interested in to see how it looks, you don't need the object out. So what you do, you just put a semicolon. At the end of the command, put a semicolon. So if you do that, it looks a little cleaner. Similarly, plt.show you can use. So instead of semicolon, you can use plt.show. So it only shows the object, right? Which is the graph. It only shows. That means what? The object exists. Okay. So when I do plt.scatter, it's only showing the object. All right. So this is the display. Now, as I said, there's a nice increasing trend. So as you can see, x-axis is, I don't know what is x-axis, y-axis. That bad, right? That's how bad the visualization is. So we need to start putting, labels and titles and things like that. So let's start with the title. Okay. So again, I just have plt.scatter and here I have plt.title. This is the way to put a title to your plot. Scatter plot of horsepower of car versus engine size. Okay, this looks a little neater. So now it looks like at least I have a title and it looks a little better. Yeah, Sonal.
Sir, I'm having one more question. So here we have taken x-axis में engine size and y-axis में horsepower. So how we will decide, sir, which one we can take for x-axis and which one we have to take for y-axis?
Again, good question. As a mathematician, I will say it doesn't make a difference, but I'm supposed to be no, just a joke, yeah, come on. But I'm supposed to be discussing data analysis with you all, so let's talk about actual data analysis. So y-axis is usually the thing that you want to track.
Okay.
X-axis is usually the thing that you can't do anything about. Think of that way.
Okay.
So in this case, I am using engine location and horsepower, right? In this case, I'm using engine location and horsepower. So I'm not saying you can't change engine location. Engine size, I think. Yeah, engine size. So I'm not saying you can't do anything about engine size. I mean, in a sense, you can, right? So suppose you have 2 cars with 2 engine size and you have horsepower. So then you can ask the question, can I choose between the cars, right? Based on engine size, then you'll get a different horsepower, correct? So here, of course, it's a very good question whether engine size is actually a good x-axis value. So in many cases, when you do scatter plot, as I said, in mathematics, you can just interchange it, right? So we are just trying to see what is the relationship between engine size and you know what, I'm just going to go put the label, then we'll talk. Okay, so here plt x label y label. Okay, I hope these commands are easy and clear. It's very, very simple. Plt dot title puts the title, plt dot x label gives the x label, plt dot y label gives the y label. Now that that is out of the way, please execute that. As you can see here, as my engine size increases, horsepower increases. Now, just to sort of show you guys, right, I can put this here and I can put this here. Okay, you'll get a very similar, it's just flipped diagonally, nothing else, it is just flipped diagonally. So in these cases, what we are doing is we are seeing, is there an impact of engine size on horse, right? Now if you think physics, horsepower typically is not going to have impact on engine size, right? Engine size is going to have impact on horsepower typically. Oh, by the way, the labels are wrong. Why are the labels wrong? Because I've interchanged, correct? So I should interchange the label also. So I'll put here scatter plot of what, of engine size of car versus horsepower. Okay, of engine size of car versus, and run it again. Yeah, so this graph will look a little weird, right? So when you present and by the way, this whole visualization business has two objectives. Okay, one, we need to be able to see what's going on with our data. We need to understand our data, so visualization helps us. Two, when we present our data analysis to individuals who will not like the numbers and the numpy and all those things, for them we need to be able to make this intuitive and easy to understand. These are the two primary objectives of visualization. Okay, so both of them of course have direct impact in our business. Anyway, so this graph, if I show somebody, they will feel weird. Why? Because x-axis has horsepower and y-axis has engine size. So it's almost like I am saying horsepower is impacting the engine size. Now, of course, you may, when you're designing car or whatever, maybe that's, you do some calculations where you're thinking 150 horsepower, then you're thinking, oh, my engine size is this, possible. But typically when you show this to someone who's doing an analysis of revenue and things like sales, things like that, obviously they want to see, okay, this car has this engine size, therefore it has more horsepower. This car has smaller engine size, therefore it has less horsepower, right? So that subtle understanding of which variable is considered as independent versus which variable is considered as dependent changes from context to context. Okay, so two ways to look at it: x impacts y. Other way to look at it, what is relation between x and y? In that case, you can just interchange. All right. Yeah, I mean, if we keep asking these good questions, okay, let's move on. With this, okay, so we understood this, right? So why don't we try something else? Okay, now let us say, what is relationship between CT mileage and horsepower? This case, it is definitely not clear what is the independent, what is the, so you can definitely, okay, CT mileage and horsepower. I don't know. Maybe you want horsepower as x-axis. I don't know. I'm going to treat it as relationship between the two. Now notice everything is same: scatter, title, x label, y label, and I've given the correct variable names. And there's this thing s equal to 10. Now if you notice here, these dots are really big, very big dots, and sometimes big and bulky doesn't look good, correct? So s is essentially the size of the markers that you are using in scatter. So I put s equal to 10. You can of course check the defaults later, but s equal to 10 gives me a smaller dot size. So you compare to this is bigger dot size, and here s equal to 10. So if I do 100, I don't know what's going to happen. Okay, it's worse, but yeah. What about s equal to 50? Looks almost the same. No, slightly bigger. Okay, so you can use s to control the size of the dots. One thing to remember is, for each method, please check what are the parameter names. This will become more obvious as we go forward. But for scatter, it is s. And by the way, when you do all these visualizations and things like that, and when you're stuck and you don't know parameter name and all that, GPT is one, right? So there are way too many parameters, by the way. So Seaborn and Matplotlib, the number of things you can do parameter wise and combinations of parameter wise, definitely, I would say pandas is easier. NumPy and pandas definitely easier. So Matplotlib Seaborn you use for a lot of time. You start getting used to a certain kind of style that you like, right? It's part technicality, part artistic, isn't it? So some of those things you'll have to research, explore which parameters you feel like fiddling. All of that is quite exploratory in nature. What I am teaching you is how it works. All right. So some of the parameters, s equal to 10, reduce the size. Great. And from here on, what we will do, we will use the same code and we'll keep adding things. So now if you see, we've added the title, my dots are smaller, horsepower, size of engine. Okay, great. You can even change the marker look. So right now the default is filled in circle, correct? So there are many marker shapes that you can choose from, right? So there's this up arrow looks like a triangle. I think looks like a down triangle. Then I think greater, lesser, these will look like, arrow pointing left, right? All sorts of different shapes are available, given to you by Matplotlib. Okay, so here say I want it to look like a triangle facing up. So then I just do marker up. Let me just increase the size for a second. Yeah. So now you can see, right? Triangles moving up. So there are like about, I don't know if I remember correctly, and don't quote me on this, please check the documentation, but around 30 something should be there, at least around 30 types of markers, 25, 30 should be available, if I'm not wrong. So, marker gives you the shape of the marker. Then one more thing is alpha. This is, one of the more important parameters. So what this controls is the transparency of your markers. Okay, so each of these, if you see, some of these areas are getting really dark, right? These triangles together getting really dark. You don't even know how many triangles there are. So if you want to look at your data a bit more clearly, you can use alpha to reduce the transparency. Okay, so if I just add the alpha, now you can see, I think everybody is able to see, right? The transparency change. Let me just put a higher size. Yeah, so from this it's very obvious. There's 1 point here, 1 point here. Clearly there are 2, 3 overlapping points here. See, this point, this idea was not clear to us before, right? So here if I put 100, obviously I don't know where there are 2 points or 3 points. This looks like 1 point to me, this one, right? This is what, 200 versus 210 something, right? Or 190 versus 210. This one looks like 1 point. But when you change the alpha, it becomes very clear that this is the light test, which means this is 1. This is obviously more than 1. Okay, so alpha can give you a better idea of, where your points are. And this is what I kind of told you about real data. The stuff that we remember from school and all of that, right? That's really nice little data here and there looking like a nice curve, right? Real data looks like this only, right? So this is why we need all these methods to see what's going on, and that's kind of, the skills that allows us to be, enables us to be good data analysts. Okay, finally we can also, change color. And the, what do you call, the parameter for color for scatter is C, and there are some codes. So for example, if I just do haha, it should give me an error, right? Haha is not a color. Yeah, so in the error, see, it says C argument must be a color, sequence of color, sequence number, not haha. Okay, so go check the Matplotlib documentation for what is an allowed color label and what is not allowed color label. So R, for example, it is red, obviously. Okay, so if you don't like the marker size, you can do 100. And this is actually not that clear, if you ask me. The blue one is clearer. Anyway, so so this is what a scatter plot is. So and one more thing I want everyone to understand is we are learning two things right now. We are learning the concept behind each of the visualizations, why we need it. We are also learning the tool called Matplotlib and how to create that visualization, right? So it's a twofold objective in this session. Seaborn also, next session also twofold objective, right? So that's a scatter plot, the most simple. Shri Prakash, not important. Okay. If you just don't want the text output, you put semicolon, or you can do plt.show. Abhishek, absolutely not required to remember all the parameters. I don't remember all the parameters. Okay. As I told you, if you quiz me on NumPy pandas, I might still, be able to answer most of your questions. If you quiz me on these parameters, my God, there are way too many. Yeah, this is here to make our lives easier, guys. Visualization, Seaborn and all. Come on, right? So yeah. Okay. Right. Okay. So this is what a scatter plot is. What's it for? It's for analyzing the relationship between two variables. Typically, we can see things like increasing, decreasing relationship. We can see linear, non-linear relationship. So scatter plot is something that we use for numerical versus numerical. Okay, that's what a scatter plot is used for. Numerical versus numerical. Let's also look at another kind of plot. Okay, called the line plot. And for this, the command, if you can see here, it's plt.plot. That's all. And the line plot is actually more useful for time series analysis. If you do a line plot, like as Sonal was asking, right? To some extent, size of engine and horsepower, makes sense. Okay, what value of size of engine gives me what horsepower and what is the relationship? But a line plot is going to look like a line. So later when you have time, just change the entries to engine size and horsepower instead of the other data I'm showing you, change the entries, it will look like all crisscross. Makes no sense, right? Just imagine how many points are here. How many points are here. So now if I use everything, a line to connect everything in the order of the x-axis elements, just imagine how bad that's going to look, right? So typically line plots are only used for time series data. So here I'm reading another data set. This is also quite common data set, air passengers. So let me read it into DFAP, air passengers. And basically it has like the month of on which the aeroplane flew. So basically what it has the number of passengers in the aeroplane basically. So there's airliners and how many passengers are going inside that aeroplane. So for example, here January 1949, 112 passengers. Was this February 1949, 118 passengers? As you can see, it's an older data set, but it's very common. Okay, so this is something that we would like to analyze, like a line. So I can do scatter plot. I can definitely do scatter plot, but it looks better if you analyze it as a line. Okay, and let's just quickly check the info. 144, 144, 144, nothing to worry about. Okay, do note that month is object. Okay, month is actually object, but I think it's all sorted. Okay, now Jan 1949, was this Feb 1949, so on and so forth. If it's not sorted, and this is something I would also request, anyway we're doing data pre-processing and all that later, but you guys should start exploring this, right? So for example, how do I convert month, which is right now object, into date time? And I think if anybody has been trying to solve price pulse assignment, yeah, there are some date time activities in there, right? So there's a methods for that, and then you can sort it. Once you convert it into date time object, you can. Anyway, this looks sorted. Yeah, as I told you, you can do plt.plot. Now before we do this, let me just do plt.scatter. Okay, before doing this, I'm going to do plt.scatter. Okay, increasing. What does this mean? This means that as we got closer and closer to today, which means as we as we go into the like more future time, the number of passengers in the airplane keeps increasing. Okay, so this could be because of many factors. Again, you should go and check the data and study it further. It could be that the aeroplane got more seats. I don't know how. It could be that people started believing in going in aeroplanes as time went on, right? So it could be multitude of factors why this is happening. Okay, and again, this is where our job as a data analyst starts. Okay, why is this like this, right? You ask the why question, you ask the how question, and then you use all of this to get mastery of your data, and then start asking those questions and being able to solve those questions. Anyway, so okay, scatter plot looks okay, but now this is where the magic starts, right? So now if I just do plt.plot, so by default plot gives me line plot. If I do this, see this beautiful pattern. You obviously nobody can see this pattern here. Okay, nobody could see this pattern in the scatter plot. Look at this. There is clearly some seasonal effect going on, right? This could be holiday season, right? The peak is up because maybe it's Diwali or Christmas or something, right? And then it goes down, and then again it's up. What's going on? So time series analysis is typically done using this thing called line plot. All right, it gives way more insight into the data. Okay, one thing is very obvious, that the x-axis looks very bad, right? If you can see here, this looks very, very bad. And I think the reason is that it is plotting all the days. Okay, so it's not only restricting to month. So if I just go and check info, I have 144 entries from 0 to 143. Each of these is January, February, March, April, May, so on and so forth, right? So 0 to 143 goes from this 0, 1, 2, 3. These are the values. So what I can do here, right? I can so here what is 23, 24, 144? 144 is nothing but the ending of your data frame, right? So 144 is nothing but size of the data frame, so it's last entry, right? So the size, it is exclusive, which means my values will stop at 143. What is this 23, 24? It's basically going in 2-year cycle. So I'm trying to restrict my x tick. So these things here, these are called ticks. Okay, so I'm trying to restrict them to 2-year cycles. So that's why I have 24. Okay, 24 months, right? So I'm starting 23 steps of 24 till 143. So x ticks, and you do that it will only show you some of those, right? It will only show you those X ticks. So here you have 23 and then 47 and whatever. So you will get the X ticks shown only for the index that you chose. So here you have indices 0, 1, 2, 3, 4, right? So wherever this index is 23, it will take the month or whatever, it will show that. Okay, so 1950 December, it is showing that. And then 12th, what is this again? December 1952, 2-year cycle, 1954, 1956. Okay, so this was looking bad, and you can do this. Now, feel free to play with this later and sort of try to get a better X tick the way you want. Depends on the analysis you're doing and who you're showing this. Another thing that, yes, I have a doubt. Yeah, Abhishek.
Can you, sir, can you again explain the text ticks? Means that this one range, I got
Range.
confused.
Okay, so just see here, right? If I just put df ap, okay, and if I do df ap dot loc23, what is the month here? 1950 December, correct?
December.
That is my starting value.
Okay.
So if you don't put the X ticks, what happens is it is showing you all the X ticks. Oh, okay. I hope we all understand that what's going on here. It's not a black line or anything. All the text has been put, which is why it's looking bad. January, February, March, April, May, everything has been put, which is why it is looking bad. Okay, it's not some error. Okay, this is not some error. All the text has been put. Okay, so by default, it is putting all the X ticks. Yeah. So this is what I think. Someone else also had asked, a question in which I said Matplotlib will allow you to do anything. Right? It is the backend. Yeah. So here we need to do additional effort. So this, typically this will not happen in Seaborn. Typically, this will not happen in Seaborn. Okay. It's, as I said, more intuitive, more human friendly. But in Matplotlib, it will happen. So here, so 23, I'm taking January 1950. And what does range do for you? It goes in steps, right? So the step size is 24. 24 means what? 2 years, 24 months. So then it will go 2 years means this is December 1950. Then it's going to go to December 1952. So that is what is being shown here. Okay.
Okay, sir.
Yeah. Okay. Great. So all this is nice. As I said, one more thing that I would like to do here is, I want to see the real data. So one thing you need to understand in line plot is you are showing fake data. Please remember and please understand. So wherever you put solid value, you are assuming that it is increasing or decreasing in that behavior. But actually what you've done is you've just connected dots. So the connection is fake. I won't say fake, but it's not real. I don't know how else to explain, right? The connection is not part of the data set. Dots are part of the data set. Okay. So one good practice is to show the markers. So when you show the markers like this in line plot, in time series line plot, it is better practice because then it is clear, okay, these dots are actually my data points, my real data points. And this line is just there for me to do some, visualization and analysis. Okay. So again, the command here is, parameter here is marker. Okay. One thing is, the default marker size is not good. Maybe you don't like, this is really bad. What is going on here is looking really bad. So then you change the marker size, right? You can go ahead and change the marker size. And I don't know what else I've done here. What have I done here? Oh, yeah, I was going to say that. So the one thing is, see, it feels cramped, right? So when you plot this, it feels very cramped. So what's happening is there's a default figure size, which is what within which you are actually putting these elements. Okay, little bit soon we will see the object that we've been discussing till now. As I said, each of these commands, plt plot, plt scatter, it creates an object. Where is that object? You can actually output that object. Like, what do I mean by object? I mean data frame, series, numpy array, whatever, right? So matplotlib figure is actually an object. You can store it in a variable. You can pass it to some other function, right? It's an object. What you're seeing here right now is the, display. So that's what the semicolon is doing, right? Someone else had asked, is it necessary? Well, the semicolon forces only the display. Means the output will not come. I hope we are all understanding this language. What I'm looking at right now is the display of the output. I'm not looking at the output. I hope that is clear. The output of all these is actually an object, which we will see soon. What we are looking at here is the display of that object. Okay. So basically, if I take this matplotlib object and display using some other library, I'm going to have problems. I'm going to have errors. So here I'm using plt.show. okay, or I'm using this semicolon shortcut, but basically they do the same thing. I'm using Matplotlib to show Matplotlib object, which is a graph or a figure. Yeah. So anyway, it's all cramped. So what do? You just need to change the figure size. So here is where, there's what you do is plt dot figure, and let's use this right now and see what is this figure a little later. It refers to the complete figure. Okay. So basically every sort of the whole canvas, you can say the whole canvas on which you are putting X label, Y label. And by the way, till now we've been discussing so many commands. I hope it is at least intuitive, that it feels like I am putting the object on the canvas, isn't it? When I do plt X label, plt Y label, whatever, I am putting, items and elements and objects on the canvas. Same thing for plot also. Okay. So when I do plt.plot, it calls a figure. On the back end, it actually calls a figure. So here, when I do plt figure, I'm calling that figure before the plot, the canvas. So when I call the canvas before the plot, now I can set the size of the canvas. Okay, so there's a very, very important parameter called fixed size. Again, 10 means horizontal. So whatever the first number here, this is the horizontal, and 4 is vertical. This may sound very counterintuitive, and I would agree that it is. Usually we think that the first number is the number of rows and the second number is number of columns, but here the first number is actually, you can say, size of the horizontal. Okay, the second number is size of the vertical. So I'm increasing this to 10 and decreasing this to 4. Everything else is the same. Now you see it's much cleaner, right? This is much cleaner to look at, much neater to look at, easier for me to speak about it when I show this to my team or my business head, right? Much easier for me to speak about this graph, right? I can just say, hey, the data that we have from 1940s, 48, we have till 1960, 12 years, and our airplane, our airline, as you can see, typically there is an increasing trend, but we can see almost 1 year cycles. I think these are half year cycles actually. So from here, how to count? 1954, 1956, these two are December, right? So this is exactly half. Yeah. And then, so this triangle looking thing is happening every half year. Yeah. Not half, 1 year, sorry. So half of 2 is obviously 1, right? Each gap is 2 years right now. So this thing is happening every 1 year. So it's easier now to speak about this when it looks better. That is the thing that I'm driving at here. And if you do deeper analysis, you can find out what is going on here. I don't know, where are these peaks happening? See, this is happening around what, November, October, November, something, isn't it? Okay. Anyway, so I'll leave these kinds of questions for your imagination, and we'll move on. Okay, so finally I spoke about this thing, right? X limit and Y limit. So the commands are plt xlim, plt ylim. Okay, so here you can specify which section of the actual data points to show. In other words, if I want to cut my X limit at, I don't know, 1954 or something, then I will start my X limit at 1954 and go till 1960. So for this, you can go back to the index and see where is 1954, where is 1960. Okay, so then you use the index to cut it. Y-axis also similar. See, the values are 600, 500. If I don't want to show more than 500, I can actually cut that. Okay, so we do that using xlim and ylim. So here I'm putting xlim 0 to 150. Oh, when I say cut, obviously you can show more also. So if you put your X limit more, it's going to show blank space, which is what is going to happen here, because I think, yeah, I have only 144 indices, but I'm telling my xlim to go till 149. Sorry, 150, right? So there will be some white space. So here I think there will come some white space, and here I'm saying go from 0 to 750. Okay, so I don't know how much is this. This is around 650, and I'm creating more white space here. So let me just run this. As you can see, more white space is created here, more white space is created here, and this has gone from 0 to whatever. Okay. Here also, as I said, you can sort of play around with this xlim ylim to cut or expand. What are categoricals? Categorical variables, as I said before also, these are things like gender, these are things like car body, which have levels. Okay, so levels or classes, right? The language used is class or level. So gender has 2 levels, male and female, or 2 classes, male and female. Car body has sedan, wagon, something, right? So it has a finite number of levels, and these are discrete values. Okay, there's no value in between 2 values, right? There's no sense of ordering as such. There's no numerical order. These are categorical variables. Typically, you can say these are categories, right? How do you split your data into two or more parts based on some attribute, quality? Okay. So for example, in the car data, we can ask the question, how are the cars distributed over different values of the door number feature? If you remember last time we did a question, I think, which was, are more cars having 4 doors or 2 doors? And we answered that question using mode or value count or something, if I'm not wrong, right? So quickly, let's check df info. What we are looking at is door number, and here door number, if you see, it's a string, which means it is not a numerical, it's a categorical feature, right? String, object, both are categorical. So basically we can do value counts, and I hope we all remember df value counts, right? The output of this is a series, point number one, and the index is the values, unique values, 4 and 2. And where do you get these unique from? There is a method. So if you just want the names, you can do dot unique, right? Anyway, so if you do value counts, you will get the value and how many times it has occurred in your data set. So 116 cars have 4 doors, 88 cars have 2 doors. What is a good visualization for this, right? So what we are actually trying to do is pie chart. Yeah, Abhishek. And the command for pie chart is nothing but plt.py. Okay, so plt.py, and what I want to do here is I want to pass the values. In fact, you can actually check what happens if I pass the series. It will take the values by default, right? So pie chart of distribution of cars based on number of doors. This is the title that I've given to my pie chart. And if I just pass the series, obviously it will take the values, right? Because by default, if you say series equal to something, you are actually talking about the value in the series, not the keys, right? If you want there to be labels, then you have to split it between values and index, for example, right? So plt py, whatever your values are, and then whatever the labels are. So if you do that, now you will get this labels 4 and 2. Okay. So these are here 4 and 2, 116 and 8. Obviously, this 116 and 8 are converted into degrees. Okay, converted into angle, and that's what it is showing. Now, if you want this to look even better, then you should have both pieces of information, which is what is the type of the car you're looking at, which is 4, and how many are there, right? So this door number value counts index 0. What does it give me, right? Again, let me print the series here. Index 0 will give me 4. Index 1 will give me 2. Value counts 0. This series, right? Whatever the series is, the 0th element gives me this value 116, and the first element gives me 88. I'm converting these two. Obviously, these are integers. I'm converting to string, and then I'm adding it, concatenating it with this string. So I'm just creating some labels so that it looks better. Now, if you see py labels, which I've created here, it's just a list of 2 strings. Now I can use this to label for my pie chart. So plt py values, and now you change label. Don't use this index anymore. Now you can use the new list. Okay, so if you print this, now it looks a little better. 416 cars to 88 cars. So pie chart is obviously one way to investigate categorical variables. So what is this telling? It's saying that more cars in my data set are of 4 doors, and less is of 2 doors, right? Pie chart is one thing, but interestingly enough, the more common chart, and I think we all know this, is the bar graph, right? Or the count plot. And what we call in data science language as count plot is nothing but a bar graph. So we know what bar graph is. These are just x axis has categorical class values like 2 door, 4 door, whatever, gender male, gender female. These are the x-axis, and y-axis is recording some kind of numerical value. So it could be the number of cars which are 4 door. It could be the mean price of the cars which are 4 door. So y-axis is some kind of numerical value which pertains to each of those levels in the x-axis. We'll start with count plot, okay, which is the most basic kind of bar graph is actually a count plot. So and again, same thing, right? Value counts. And suppose the question I'm trying to answer is how are the cars distributed over different values of car body feature. Okay, so df car body dot value counts, this is what I need. It gives me each of the values, the classes, and the count, right? How many of these exist in my data. So one thing I want to show you here is, as I told you before, that these are actually objects, and then you're displaying these objects. What exactly are these objects? These exactly are the objects. So fig comma x, okay, it's actually a tuple. And the command that you're using is plt.subplots. What it does is it initializes a figure and an axis basically. So if I just do this, if I just say fig comma x equal to plt subplots, as you can see, it is displaying an empty graph. Right, it is giving me two axes from 0 to 1, and then it's giving me empty graph, and the whole thing, the canvas where all this is put, this is the figure. Okay, so those are the two objects which are actually there in all of these graphs, all of these that we've seen till now. These are the two objects: the canvas, which is the figure, and then the axis. So each axis is going to have properties like bar and things like that. So if I just do type fig, it says matplotlib.figure.figure. Okay, so similar to panda series, right? Matplotlib figure. And if I do type ax, that is matplotlib.axis. So this is an axis object, this is a figure object. These two things together are used if you want to do a little bit of more tweaking. Okay, so what we saw before is called scripting. So this is what we typically use, by the way, if you're doing not going very deep into changing your plots and things like that. This is what we will use, scripting method. This method is available if you want to go a little bit more into the backend and change things. Okay, so the way to use this is fig ax equal to plt subplots. Now you have your figure and your axis, right? This thing you have. On the axis, you can start plotting things. One thing you need to remember is the methods are now different. So if you remember plt, here it says plt title, correct? So here, when you are accessing the command from the object, right, the name of the function is different. So the matplotlib function to put a title is plt.title. But if you want to change the title on a certain set of axes, then you have to use .set title. So as I said, there are like multiple methods and parameters and things to remember here, and you shouldn't be trying to remember all of these things, right? So just think about it. Just changing the title of a figure, is that something that I remember how to do that, changing the title? We can change the title. It's not a hard thing. What we should be focusing on is the core things, right? Things like, what insight can I get from this? What is the meaning of things like correlation? All this you will see later, right? So my point is not to get overwhelmed with this kind of stuff. As I said before also, way too many parameters, methods, things like that. I also don't remember everything, right? Anyway, so but I do remember that the functions are different, so I can go check. So on this ax object, which is two axes, x and y axis, the way to create a count plot is by using bar. And as I told you, count plot is nothing but it's a specific kind of bar graph. On the y-axis, you have the count. So ax.bar, and then what am I using? Car body value counts index, which is sedan, hatchback, wagon, hardtop, these things. And car body value count dot values, which is 96, 69, 25. Okay, and you can set an x label using set x label. You can set a y label using set y label. You can set a titles using set title. All of these are pertaining to the axis and not the figure. Okay, so figure has certain properties like figure size and things like that. Axis will have certain properties such as the elements that you are putting on the figure, right? And they will be controlled by the axis. So in that you get x label, y label, title. All of these things come in the axis. Okay, so if you plot this, you'll get a count plot. And by the way, the parallel method for this one scripting, I think it is plt bar. Let's check it out. If I just do plt bar, I'll get this. So mostly we'll be using the scripting method, right? And things will get even easier when you do Seaborn. But if you really want to go to backend and change things to centimeter dot, then you have to use the object-oriented method. Anyway, so count plot, as you can see, what it does is there's a categorical on the x-axis, and these are the counts, okay, which is why I've given y label as count. Sedan is maximum, hatchback is here, wagon is here, hardtop here, converter is here. Interestingly enough, it seems sorted. The reason that it is sorted is because value counts is typically sorted, right? So where is this data coming from? It's actually coming from value counts. So when you do value counts, you will get sorted output, which is why this is also sorted. Okay, so let's do one more count plot. So again, categorical. Suppose we are interested in the cylinder number, okay, and let's just see the feature. I told you it's better to see the feature. Again, it's a string which has 4, 6, 4, 5. And notice, guys, I don't need this to be a string. I can have the numbers 4, 6, 5, 6 and all that and still treat that as category. If I have a method which accepts integers as categorical, I'll use that method directly. If I have a method which rejects integers but only takes string, then I will convert this to string. What I'm trying to say is, don't think that numbers are always numerical. I know how that sounds, but in many cases you may want to do categorical analysis of numbers. So cylinder number of cylinders, definitely we should think of it of categories. Okay, these cars have 2 cylinders, these cars have 5 cylinders, these cars have 6 cylinders, right? So in this case anyway, these are strings, but just keep that in mind. Okay, not always numbers means numeric. Most of the time, yes, numbers means numerical, but not always. Right, so just again do value counts, right? Save it, print it. As I can see, 4, 6, 5, 8, 2, 3, 12. Very interesting. If this was actually numerical, then I should get 1, 0, 5, right? So obviously this is a categorical variable. These are the counts. So what does our method say? Method says figax PLT subplots. This is where you save your figure and axis in a tuple. I want to do bar plot, but I want the y value to be values, counts values. Okay, so I want values from this series. So this is your panda series here, cylinder number value counts dot values. So I'm getting the frequency. Okay, technical term to use is frequency in my data set. So let's print this. As you can see here, the 4 cylinder cars are the max, then 6, then 5, then 8, then 2, 3, 12. Interesting. So most cars seem to be having 4 cylinders. Don't know why that is, but it's a good question, right? Good question to good follow-up question to this. How are the cars distributed over different values of cylinder number feature and why? So that is where you will look at this as a data analyst. You will look at this, right? Then you will try to analyze this, count in terms of other variables and see, okay, is this a reason? Is that a reason? Then you will also check the domain knowledge. So I'm pretty sure this is not hard. You can just Google, I don't know, why do cars have maximum 4 cylinder or something like that. Definitely this answer should be there. Anyway, so this is how you use the object oriented method, and you don't need, all I'm saying is you don't need to, but if you want to, then each of these methods you can do, and I'll show you why. There is one example later where this becomes important. I'll show that to you. Right, and finally I want to show this. There is obviously you can use grid, like for example here, again, when you show these kinds of graphs in data reports, for example, what do you think the y value for category 5 is? It's so difficult, right, to trace back. Now I can trace back because I have been looking at these graphs almost every day for so many years. I can just trace back and say 10. Very nice. But what about people who are reading your report? So if you want to make it slightly easier, you can put a grid. So x.y-axis grid, and it gives you nice grid lines. Of course, you can now change the grid line color and things like that. I will leave more exploration to you guys and ChatGPT, right? As I said, it will give you immense amount of code on visualization. But now I can, and see, I would definitely want to change that, right? So here it's at intervals of 20. So I might want to change the y ticks to 0, 10, 20, 30, 40, whatever. Anyway, now if I ask what is 5, now it makes sense. It is more than 10, because now that I have this grid, it's easier for me to judge, okay, how much space is left between this grid and here, how much space is there from the ground till here. Clearly this is more than 10. So now I'll take a better guess. Okay, this is 11, this is 12, right? So this is how you improve your visualizations and drive your narrative. Okay, so if you're trying to propose something, then based on whatever business you're handling, right? So these are the things which can sort of help make your point clearer to those who do not want to look at the mathematics. Fine, please try this quiz, and then we'll look at bar graphs with different y values. Please try this quiz. Create a count plot using cuisine in the QDF data frame. Use any method that you like, and make sure that you have good title, good label, and just make sure the command you're giving, it's something that you can show to anybody and you can sit and explain. So as I was saying before, count plot is actually a special case of bar graph, right? You, on the y-axis, you have count, right? So how many Indian cuisine people in my data? Around 17, 18, whatever. How many American? 7. How many Chinese? 7. So count plot is just a, case of bar graph. You can put other things on the bar graph. So suppose if I ask the question, what is the average price of different types of cars? Now, when I say type, suppose I'm talking about car body. Okay, so I'm going to use the car body feature, right? And note that the question is average price of different type of cars. So I hope we all remember group by, right? So now my DF, I'm going to group by car body. So till here, this much, this produce a grouped data frame object, right? This is a group object, which means it is now waiting for, some kind of aggregation method to be applied. It's a grouped object. It's grouped by car body. From the grouped object, the group data frame, I will select the price feature, right? Because the question is, what is the average price of different types of cars? So from this grouped object, I will select price feature, apply mean. So dot. Okay. So these commands put together will give me, the average prices of the different types of car based on car body. And of course, it's a series. Right. So if you print it, this is what you'll get: convertible, hardtop, hatchback, sedan, wagon, and these are all the average prices. So now, if you notice, previously we did PLT bar, and here you did cuisine names, which is what? Cuisine counts dot index, and then this counts variable is nothing but cuisine counts dot values, index and values, where you did value counts. So this values actually has the frequency of the categories, classes. Here I'm going to give values from this series. Now this series does not have frequency, it has the mean value of the price feature for each group, right? That's what I've calculated with this group by op. So from here I'll put values, and of course index I will use the same. Everything else remains the same. So now what you're plotting in the y-axis, now you see the the scale. By default, it is now on a different scale, y-axis. Why? Because you're plotting a different thing. 0, 5,000, 10,000. These are, I think, dollar prices. So from this, you can see hard top cars are the, the average of these is the maximum. Convertible is almost close. The least is hatch. Now, one thing you typically may, and you might encounter is that some of these names can get very big. So right now it's not bad. Convertible, hardtop, hatchback, it's not bad. But many a times these names will get much bigger. So then, the text will start interfering with each other and it will look bad. So there are many things, as I said, you can do, right? So one of the things you can do is you can rotate your x ticks and y ticks, by the way. So here, I want to rotate my x ticks by 40. Okay, so same graph as previous. I'll rotate by 40. So as you can see, it has, rotated anti-clockwise by, plus means anti-clockwise. Anti-clockwise rotated by 45. Okay. Here it's okay, I said, but typically you will see that sometimes these labels can get very big and you may have many. So then you need to know how to rotate. Now, another thing which you might think of in this case is that will it not look better if I, sort the graph according to price, mean price, right? So for that, just go back to your series, right? Average prices. This is your series, average prices, and just sort it. So for series and data frames, I hope we all remember sort values. This is the method, right? Use this, and I think ascending is default true. So and I'm storing this sorted series in a new variable. Use the index and the values, same thing. But now if you see, it has now printed in ascending order, right? So basically what I'm trying to say here is, as long as you are sure of matching the order of the index with the order of the values that you're passing, this y value, x value, and same goes for scatter plot and everything else. I think one of you had asked the question, right? Does it know relation? It should be able to plot relation. My answer is no, it's not. Okay, it doesn't care. So if you mess up your data order, right, x value and y value, if you change the order, it is going to print. It is still going to display. It's not going to say this is wrong. So as long as you are sure that these two are matching correctly, like the value you're passing x and value you're passing y, then we are safe. So this is ascending. Of course, you can do descending. Same thing. Take this and put ascending equal to false for sort values and print it. You'll get the descending. Another thing you can do is obviously, these are value sorts. You can also do index sorts. Why would you want to do that? Well, sometimes alphabetical order is a convention people follow. So right now, if you see hard top convertible sedan, this is not in alphabetical order, right? So if you just sort index, and index of what? Again, average prices. What is the index? These are strings: convertible, hardtop, hatchback. What will happen if you sort the index of strings? It's going to take alphabetical. So suppose I do ascending equal to false, and let me just print it. As you can see here, it starts with, wagon, sedan, whatever. So if you want to have it in proper alphabetical order, then you can just skip this because default is true, right? And just print it again. So in this case, now it will go from convertible hardtop hatchback sedan wagon. So typically this is something which is a good convention to follow. Okay, either sort the values or sort the index, it looks better, and generally this is a convention which is followed. Or if you have a specific order for this wagon, sedan, hatchback, hardtop convertible, you can specify that, right? So here, let me just copy this again, and suppose I want the index, right? So average prices sorted dot index. Yeah. So I can change these to whatever order I want, but that's where you need to be careful that did you change the values to whatever order you want. So you need to reorder your original series if you don't want to go wrong. So here you may want to reorder the index. There are methods. I told you guys that you should, in your free time, you should see some of those pandas methods. Again, use ChatGPT. There is a very nice, I think, easy method to give the intended order for the index of the series, and it will change the values position also accordingly. Then you can print. Okay, then you can plot it. Right. So what we've seen here is that bar graph can be used to plot other numerical values. It's nothing but taking some y value for some group. That's all it is. Okay. Finally, and I guess finally, if things get really bad with your bar plot, you can always change the orientation. So this is also very common. So plt.bar, this gives you the typical vertical style. plt.bar h, that is bar horizontal, will orient it horizontally. So the index and values are the same, but now it will be oriented horizontally. So now if you see, wagon, sedan, hatchback, this is easier to read, right? This is easier to read. So you can add your title, X label, all of that, and you can also put a grid if you want. So just imagine you have the grid, you have the title and everything, and you have you're presenting this in a PowerPoint or something, and it easily allows you to explain what you're trying to say. Hey, here it's less. We are missing sales of sedan by, I don't know, what is this, about $2,000, right? You can show it, you can mark it. So choose the best kind of representation, visual representation that you want. All right. Okay. So we've seen single bar plots. Now let's explore this a little bit further and talk about multiple categorical variables. Okay. And we'll use tagged and grouped bar plots. So suppose I'm asking the question, how are the cars in the dataset distributed over door number and car body? Don't worry about the cross tab method that much. Okay. It just basically cross counts, nothing else. So this is called cross tab, cross table. Okay, the object that you're looking at is a cross table. You can do the same using pivot tables also, which again you'll see a bit later in data pre-processing, things like that, data analysis. But essentially this method just gives me the cross count. So how many hatchbacks are 4-door? 11. How many wagon are 2-door? 0. How many sedan are 4-door? 80. So if you add across the row, you get the total number of 4 and total number of 2. If you add across the column, you will get total number of convertible, hardtop, hatchback, so on. So this is what we want to visualize basically. Okay. So what I'll do here, I have columns, car body, convertible, hardtop, hatchback, sedan, wagon. I will store this in car body categories. Put it here, car body categories. So convertible, hardtop, hatchback. Yeah. This I could have got from, unique value counts, whatever, right? I could have got this from anywhere. So now what's happening is I want to plot 2 bar graphs. Now this is where let's pay a little bit attention. See, fig, ax equal to PLT subplots. This has created one figure, right? And a pair of axes. Okay. On the same axis, you can plot multiple things. That is the point. So here, if I say bar 1 equal to ax dot bar, and here if you see the x-axis, I'm using np.arrange rather than using these labels. For now, I'm using np.arrange. So what is np.arrange len car body category is going to do? What is len of car body categories? 1, 2, 3, 4, 5. So np.arrange 5 means 0, 1, 2, 3, 4, right? So it is actually taking the index 0, 1, 2, 3, 4. Okay. So I'm plotting 0, 1, 2, 3, 4 versus this. Door number car body cross table dot loc 4. In other words, I'm this row, right? What is this door number car body cross table? Nothing but this data frame. Okay, it's a data frame. I hope you can see that it's a data frame. So in this data frame dot loc 4, which means this row. So for category 4, I'm using 0, 1, 2, 3, 4 instead of car body convertible. I'll come to the reason why. Okay, to plot a bar. And what is the bar? It's nothing but count. So cross tab gives me the frequency only, count, number of vehicles. Same way, I can have another bar. So bar 2 equal to NP arrange car bodies, same thing. And here LOC 2. So now this guy here, okay? And you can set X label, Y label, title. Now when you print this, this is what you'll get. There's a spelling mistake here. So this is what you'll get. Then there's a spelling mistake everywhere, because I think we all know by now when you're dealing with multiple plots in Matplotlib, copy paste is the way to go. Otherwise, you'll keep writing every time. It's just not possible. Anyway, so here this is the output you will get. Okay, so I've written here 0, 1, 2, 3, 4. Okay, so this blue, basically what happened, the orange has come on top of the blue. So in other words, I cannot say behind this orange is there any blue. So one thing you can do is alpha, right? Like if I just take this, okay, and I say alpha equal to 0.5, hopefully this thing has an alpha. Yeah, so here you see, here the colors are mixing. So when you plot two bars, it's just, you know, on top of each other. As I told you, these axis elements are nothing but it's just going on top of each other in the order that you specified onto the figure, right? So if I do alpha 0.5, that's one way to see, you know, okay, this is my blue, I guess, right? If this is orange, obviously this is blue. But does it look good? Obviously the answer is no. This looks very weird, right? So one thing that you can do is you can decrease the width of these bars. So you know, the default width, I believe it's 1 or something. Let's see, 2 to 3. Yeah, default width is 1. So the reason I gave these indices here is to show you how Matplotlib works. So from 0 to 1, the length is 1. From 1 to 2, length is 2. From 2 to 3, 1. From 2 to 3, length is 1. So each of these bars is actually, you know, the width is equal to 1. So suppose I change the width to 0.5. Okay, you know, I'm getting somewhere. I need to now move my blue this way. I need to move my orange this way. Something I need to do, right? I need to move these two apart. So one way to do that is shift the X values for the 2 bars. So for the 4 guy, right, and I think 4 is blue, I'll decrease the width, right? So minus 0.25, not the width, the location. So if I do here minus 0.25, what's happening is 0, 1, 2, 3, 4 minus 0.25. So I'll get minus 0.25, then 0.75, then you know, 1.75, I think, whatever. So you're shifting it to the left. This bar, I'm shifting it to the right. So 1 I'm shifting by 0.25 this side, 1 by this side, which is total of 0.5 shift. So now my 2 bar graph should separate fully. And if I do that, you can see finally, you know, it's starting to look like something which we can understand. Okay, the orange is a bar graph, blue is also a bar. So if you notice the x-axis here, the blue, this blue, initially it was centered at 3, correct? And you have moved it to the left. As I said, orange is on top of blue because this is the orange one. It is your second line of code. So that came later than blue. So the blue one is the one behind blue. Okay. So this I moved to the left. So here you can see the bar has actually moved. Similarly, this one centered at 3. If you shift by a quarter, right? So this will move to the, and also because my width is 0.5. Okay. So 1 became 0.5. Then I'm moving that 0.5 by 0.25. One on this side, one on this side. So the orange bar graph moved to the right, blue bar graph moved to the left. Now this is looking good. So what I can do is, you know, at this stage, I can make it a little cleaner. So here, if you see, okay, for some reason, you know, there are no blue cars in one of these categories. I don't know which category, but if I have to see, it says convertible. Yeah, 0. So there is no car here, right? So you're getting a blank here, right? So again, that looks awkward. But barring that, this these bars are stuck together because of the perfect numbers that you've used, 0.25, 0.5, right? They are stuck together. So another thing you may do after that is reduce the width little bit. Okay, so make it 0.4 and then, you know, shift it by 0.2, 0.2 or something, right? So when you execute that, now are you seeing where this is going? So index 2 has 2 bars, index 3 has 2 bars, index 4 is supposed to have 2 bars, the other one doesn't have any value. Index 0 and 1 also supposed to have 2 bars, but the other one doesn't have any value. But this now looks like something that we can present. Okay, and here at this stage, I'm happy with all the numbers and everything. So now I can set my xticks to labels. So here ax.set xticks, and you're setting it to 0, 1, 2, 3, 4 only. So here you probably don't need this statement, right? But yeah, when you're changing the xtick labels, there is a warning which says, okay, you know, set the xticks. So xticks I'm setting 0, 1, 2, 3, 4, right? np.arrange len car body categories is nothing but 0, 1, 2, 3, 4. I'm resetting that. Then I'm giving the labels as the categories themselves. Okay, so instead of this 0, 1, 2, 3, it is now convertible, hardtop, hatchback, sedan, V. Okay, I want to summarize this by saying in Seaborn, we will not be going through so much trouble. Okay, but the whole point of Matplotlib, as I told you, is it works on the back end. and what we are doing is we are getting a nice look at the backend. So this is how you can create a grouped bar chart. All right. Yeah, and finally you can put a legend, right? So the command is ax.legend. Now this will not work if you don't change the label. So if you see the previous here, there's no label, and we are already suffering without that label, right? I'm looking at this blue and orange, I'm saying this is door 2, this is door 4, whatever, right? So again, think about it. When you're having a business meeting, should we be, blue is on top of orange, therefore it is blue, blue door or 2 door? No, right? There should be legend. So for legend, you need to label your graphs. If there are 2 graphs, you label them. So here I add a label for, label is kind of name, you can say, right? It's a label for this bar object, right? So this bar object, start thinking that way, right? So this blue thing plus this blue thing plus this blue thing plus the empty stuff here plus the index values, right? Plus the y. That's one sort of set of objects, right? The blue columns is an object. It has a name. The axis has y labels and ticks, x labels and ticks. Those have certain attributes, right? And if you don't set all this, we've already seen, right? If you don't set all this, what's going to happen? You're going to get a blank graph, and you're going to get what? 0 to 1, 0 to 1. This is default. So what you're doing is you are changing each of these elements separately. Okay, that's what's going on here. So bar 1 is an element, it has a label. Bar 2 has is a bar, it has a label. You set here x label here, so now that's an object. Y label is an object, title is an object, xtics is an object. So this is how Matplotlib actually works, to build visualizations. And the thing you need to remember is it is one on top of each other. That's what you need to remember. It's layer by layer by layer. You are adding these components. Okay. So yeah, legend is something that you can always have. So ax.legend. You can, if you're doing scripting, then it's plt.legend. Okay, in this case it's the same. And if you just call the legend command, it will take the label and it will show legend. Now suppose I don't have the label, right? What's going to happen if I do legend? It's going to warn you, right? No artists with labels found to put in legend. Okay, artist means, okay, this is an artist, it should have a name. As I said, this is an object. I'm using the term object. Matplotlib wants to say artist, whatever. Point is, there's a warning. Okay, so now if you just put your label and then put the legend, it knows, okay, this object or this artist, as Matplotlib says, the label is 4, and this artist, the label is 2. And now you know, okay, orange one is 2-door cars and blue one is 4-door cars. So this visualization now you can use in a report or a PPT or whatever, and then say, okay, we know that hatchback and sedan are the maximum number of kinds of car we have, but within those, are there more 4 or are there more 2? So by looking at this, quickly you can come to the conversation. Okay, the maximum number of cars are 4-doored sedans. Okay, which I think means Maruti Swift, Suzuki Swift. These are exactly the cars, right? 4-doored sedans. These are the maximum. And this could be, for example, this is a car price data. You might be doing a sales analysis, right? So there also you may be having these questions. What kind of product is selling more? So, all these kinds of visualizations will help drive those kinds of insights and conversations. Okay, Abhishek, is that the answer for this? Or if not, let's do this quiz. I thought we already solved this quiz. Okay, quiz guys, create a bar graph of the average expenditure for different cuisines in QDF. I hope we all know what we need to do, group by all of that, and then bar. Are we all following everything till here? Yeah. And just to reiterate again, we are, expected to know most of the basic NumPy pandas, how they operate, right? And as I said, those tools by themselves, do nothing, which is why we did a lot of hard work trying to familiarize ourselves with the tools. And now, if you see, I'm using so many commands everywhere. And this is what I said, right? And slowly you guys are now much more familiar with programming, commands, data types, all of these things, right? So that familiarity now allows you to appreciate what's going on, in analysis and visualization, things like that, right? So yeah, that was just something that I wanted to point out. Okay, it is very difficult if you want me to teach the tool called pandas and group by and mean and the visualization. Just think about it. Is it possible? Is it possible to do all of that? No, right? Which is why we go through the tools first. Okay, so we've seen quite a few different kinds of plots, right? We saw pie chart, bar chart for categoricals. We saw scatter plot and line plot for numericals, right? and I believe histogram is something which is kind of important in data analysis, which histogram is something we'll see again and again. I mean, till the end of the program, I think histograms will be important, very important. So suppose the question is, how are the prices of different cars distributed? If you remember histogram from school, it's basically that blocky thing, right? So we all remember it as, bar graph has spaces between the bar. Histogram does not have space between the bars. Why? Because it's numerical x-axis. Bar graph is categorical x-axis. Correct. So histogram is nothing but the visualization of a frequency distribution. You will learn frequency distributions and all these things in much greater detail when we do statistical inference. Okay, that time we'll go deeper into all this. But essentially, it's a frequency distribution, right? A value or a variable is taking different values, right? So in this case, price is the variable. It is taking different values, $1,000, $2,000, whatever. Each value has a frequency, correct? So the thing about histogram is that it is plotting the frequency of the taken value of a certain variable. So the way I like to remember is like L shape. Okay? Logically, I start with a variable. I have the values that the variable it can take, and then I have the frequency. Same thing for bar graph. If you are using count, histogram is only for count. Okay, that's the difference. And of course, it's for numeric. So the command is pretty simple. plt.hist df price, and question is, how are the price distributed? X label, Y label, title. These should be obvious by now. Very interesting. Okay. So what it has done, and you can see these rectangular blocks. So what it has done is it has considered all the different prices between 5,000 and I believe whatever this is, around 8,000 or something, right? Wherever this bar is, it has selected all those prices and put it in one bucket. We also call this bin. Okay, so this bin 5,000 to 8,000, it has 80 cars. So basically you can say cars prices ranging from 5,000 to $8,000. They are 80 out of 200, which is about 40% of the market, right? That's a conclusion you can make. You can also say that the distribution here looks exponential, which means the higher the price of your car, the less likely that it is there in the market, right? So that should be obvious though, right? So $35,000, $40,000 cars, why would there be so many cars of this price? So this gives you now a sense of what's going on in the market, right? Gives you more information, more insight. Okay, I told you bins. Now if you see 1, 2, 3, 4, there are some number of bins. This is actually taken by default. Okay, in Matplotlib you can specify the bins. You can also specify the bin size. I will show you operation for bins. I will recommend everybody to try to change the histogram by specifying the bin size and the bin value. Okay, so I'm showing number of bins here. So here if I say bins equal to 5, now you will get only 5 bins. See, one here, one here, one here, one here, one. Okay, so how the histogram takes the values depends on this bin or bucket division. Okay, so bucket division or bin division you can do many ways. You can do by specifying number of bins. You can do by specifying size of bins, and you can give the values also where you want the bins, right? So that's something that I think you all should explore. All right, so this is a histogram. All right, gives me a sense of the distribution of the prices. Now suppose that I want to ask the question, okay, I understood the price distribution of the data set, but can you tell me the price distribution for 2-door cars and 4-door cars? So what we'll do here is, as I said, there are many methods to do this, but what I will do is I'll create 2 data frames, right? I'll take df door number equal to 2. So here I'm subsetting the data where door number equal to 2 and door number equal to 4. So I have 2-door df, 4-door df. And if we all remember our value counts correctly, this should be 88, yeah, and this should be 116. Okay, so now I have split my data set into 2 parts. Again, as I said, you can just directly do plt. It is just going to add elements on the figure. So when you do plt.hist 2-door price, so histogram of this data frame and the variable price, right? And in fact, you can directly just take the price column here, okay, and use a simpler variable here. But whatever, this will throw a histogram on the figure. Then again, you're doing plt hist 4-door df price. It will throw another histogram on the figure. What do you think is going to happen? It's going to overlap. Same thing that we saw in, what was that, bar graph or something, right? Same thing we saw. Okay, so what are the methods to do here? One is alpha, but are we, do we really think alpha is good? Right, changing the transparency, maybe, but there should be better ways of presenting this information. So this is obviously very bad. One is hiding the other. This is weird because of the way that colors are mixing. So what we can do is we can stack the histograms. Okay, and if you notice for bar graph, for grouping, we sort of had to do a few operations. For hist, Matplotlib does offer you a parameter called stack. In fact, as you can see here, I am passing the two numerical variables, which is price of two-door cars and price of four-door cars. Clearly, these are two different series, correct? A list of the objects I am passing. So this is a list within which I have the first element is this series, second element is this series. Okay. So hist actually takes multiple arguments if you want, right? So I'm passing both the data. Let me keep alpha equal to 0.5, and in the same order as this, I can also give the label. So label is also a list. Now note that such behavior may not be true for other plots, which is why we have something called Seaborn, which tries to generalize and bring everything to the same say intuitive programming sort of language, right? So that's what Seaborn does, and it does it very well. By the way, when we do Seaborn, we'll see all these commands will become much smaller. But yeah, the hist command does allow you to do this. And here there's a parameter called stack. And if you do stacking equal to true, what it will do is it will put one on top of the other. So in a sense, here you can compare the sizes of the bins for the various bins. So these two bins look almost exactly the same, correct? What is this, 5,000 to 8,000? This look exactly the same. Here the orange one looks much bigger than the blue one. Now of course you can say the same thing by looking here, but this looks bad. We can use this plot obviously. So 8,000 to what is this, 12,000? The four-door cars are more. So in the 8,000 to 12,000 budget, the market has more choices for four-door cars and less for two. Interestingly enough, for 33,000 to 36,000 budget cars, the market actually has more blue choices, more two-door cars. Okay, so something is happening here, right? You may want to ask the question, why? The more expensive a car gets, why is it two-door cars? Now most of us, right, we do have some sense of the general knowledge. I don't really have the full sense, but what I can say is that if I look at all these very expensive cars, they are these cars with two doors which open this way, very stylish sort of cars, right? So there must be something in the market which is driving that. As you can see, this thing, this visualization is giving me so much insight, right? And this is now linking to my experience. That's the biggest point, right? So if I see everywhere all these four-door cars are normal cars, right? Your Swift and your Ambassador, whatever, these are all four-door sedan, whatever. But if I do see a car which is like, it has two doors which open this way, definitely it's high end. We know the prices, right? So my experience is linking with the data. Okay, so now I can actually validly ask the question, what's going on here and why? So that's kind of the power of visualization analysis, things like that. Puts everything on paper. Okay, finally, I just want to discuss now one of the biggest reasons why we use object-oriented things here, like axe and figure. Why do we do that? For plotting different plots in the same figure. This is one of the biggest applications. This also gets easier later, but this is one of the biggest applications of this method. Okay, so you can call the axis by name. So here when I say fig ax plt subplots 1, 2, fig size. Now figure size, we know it is just going to give me the figure size. What is this 1, 2? Basically it is one row, two columns. So when I do the figure, in fact, we can print it, right? This is what you'll get. One row, two columns, isn't it? So I have one subplot on the left and I have one subplot on the right. This one. And if you change the fig size, become bigger, smaller, whatever. Okay. So this is what I have. I have two subplots. So that's what this 1, 2 is doing. Now, in all of these other cases, if you remember where we used ax, what we did not put any parameter here. Basically, we went with the default 1, 1. Okay, so the method subplots is used to generate that and this. Here you can generate now many subplots. Then when you do generate this, what happens is these objects, right? Ax object, fig is obviously only one figure. That's what you need to understand. So when I do fig from here, the figure, that is only one figure, not two figures. Ax is only, there are two as in two sets. So the left plot is nothing but two axes. The right plot is also two axes. Each of these two axes is stored in this object. axis. So you can call it whatever you want here. As I said, you can call it haha whatever. I'm just calling it axis. So axis 0 gives me this, axis 1 gives me this. So out of, if I have 1 row 2 columns, how many I have? Two subplots. So then I can call those axes or refer those axes by calling it axis 0, axis 1. Basic list index method. Okay. So then you access that axis and then plot your histogram. So axis 0, hist, 2-door, day of price, bin 20, color, whatever. So for example, if I just do this, as you can see, the left side is populated. Okay. So axis 0, left side is populated. Okay. So, and then you can do specific elements can be added to each of the subplot. So axis 0, this one, this plot on the left side, you can set X label, you can set Y label, you can, rotate the parameters, whatever. Right. Similarly, you can now call the other subplot and you plot the other histogram. I think here it was 2-door and here it is 4-door, right? And you can print like this. So and you can set separate titles. So you can see there's a separate title for each. Now notice here, set title, histogram of prices of 2-door cars, that comes here, and set title for axis 1, that comes here. What is this? This is a super title. Okay, so when you have more than one subplot, typically you want to give a super title. So what is this? It's the histogram of prices of 2 and 4-door cars. I know my super title is not very imaginative or creative, but please feel free to use this to make it better in terms of representation. And I've rotated this, maybe 10,000, 20,000. Honestly, one thing we should do here is we should not keep the X values as 10,000, 20,000. We should divide this by 1,000 and then put in X-axis, we should put price in thousands of dollars. Okay, we haven't done that. So another good thing which we should do, by the way, is price column divide by 1,000, and wherever you have visualizations, call it price in thousands of dollars. Anyway, so I hope we understood how this subplots business is working, and I hope the essence of Matplotlib we all understood. There's a figure, right? Essentially, there's a figure, and then you can have multiple sets of axes. By default, it is one, which is Y and X, a pair of axes. On that, you can now stick labels, you can put ticks, you can put elements such as plots. It could be bar, it could be scatter, all sorts of things, right? And the same thing you can do for different subplots, and you can produce as many as you want. Okay, final quiz for the session. Create a histogram of age from QDF. Audi. Yeah, Abhishek, maybe. I'm not car expert, but yeah, must be one of Audi. Or is Audi the one with the circles, right? 4 circles or 5 circles or something, right? Yeah. All right. Please solve the quiz. And I hope things are becoming clear. Why do we do data processing, data visualization, data analysis? Why do we do? Because we want confidence. The whole point, I told you long back, I don't know if I've discussed this with you guys, but the whole point of DSML, data science machine learning, is for decision making. Right. Let me see. PLT, HIST, QDF. The whole point of DSML is improving confidence in decision making, better decision making. Okay, and in many other domains, this is also called decision sciences. There are many names for data science. Let's see, plt.hqdfh. Semicolon would be nice. Fixed size also would be nice. So plt.figure, fixed size equal to, now it's too vertical. So I would do something like this, maybe. Yeah, slightly better. I would like less bin, suppose 3. Very interesting. Very interesting. Most people are young to middle-aged. Very few elderly people. That's what I can see from this data for my hotel. Okay. Another thing we can do is color. I like lavender and pastel type colors, but yeah, that doesn't, I can't even see this color. Gray. Okay, gray. So this is fine. All right. And I think 10 width is too much. So 6. Yeah, this is not bad. And bins 3 gives me a lot of information, but when people see, they might not understand. So maybe, have a few more bins to show what's happening. Okay, these are young people, so many young people, whatever. My ticks, plt dot, why ticks, what is this, 0 to 20. So 0 to 20 steps of 2, maybe. Oh my god. See, please see the output, guys. If you don't put semicolon or PLT show, see, right? It's giving you all these elements that you're creating. This is my point. When you're actually developing and whatnot, app development, data analysis app, that time you need all these objects, right? You need to pass it from control to control. Okay, why is this? I also need a title. So plt dot title. What is this actually? Distribution of ages in hotel data set. Okay, what is this? Is age. Oh yeah, I think we forgot the most important part of data visualization. Always give the units of whatever you're talking about. Okay, X is age in years, and I think Y is expenditure in dollars. How does my graph look now? Not bad, but I think this is not required. So maybe 424. Yeah, slightly better. Expenditure in dollars, age in years. Yeah, this is neat, right? This is neat, simple. And if this looks too dark, then alpha equal to not bad, I guess. Not bad. All right. Are we all clear on all these concepts?
If you're watching this, you probably love Python and coding. Introducing the Executive Postgraduate Program in Data Science and AI by IIIT Bangalore, brought to you by Upgrade. This isn't just another course, it's a game changer for your career. Here's what makes it special. You'll earn a prestigious certification from IIIT Bangalore, a leader in tech education. The curriculum is designed by industry professionals, covering everything you need from Python to cutting-edge AI and big data. Ready to turn your passion into a profession? Don't wait. Enroll now and start your journey to becoming a data science and AI expert. Click the link in the description to find out more.
So, see, last time we familiarized ourselves in an introductory manner with Matplotlib. We understood that Matplotlib is basically, a mathematical art generation package, right? So essentially it has two parts. One is the figure, and then there are elements on the figure, right? So figure has things like figure size, and there are other parameters of figure which I didn't mention, and you guys can Jupyter link. Suniti, everything's in the folder. There should be GCP DSAI _ Seaborn.ipynb. Yeah, everything's in the folder, no? Yeah, here is. Yeah, so download that. Okay. Yeah, where was I? So it's elements that you are actually putting on top of a figure. Now figure, I showed you figure size is an aspect of the figure. There are other parameters which I didn't mention, and I think you all can just explore and get to know about. For example, I think there is a DPI. DPI is for resolution, clarity of the elements, right? So high resolution, low resolution, that kind of control. So there are multiple things you can control using the figure aspect. And of course axis is the main thing, which is where you're plotting all the different elements, which is the labels of the axis, the limits of the axis, the plot, and things like that. Okay, now we also understood last time that it's quite mechanical, isn't it? Matplotlib is quite mechanical to use, not necessarily the most user friendly way of using, right? Which is where Seaborn comes in, right? So Seaborn is a data viz library which is built on top of Matplotlib. Just like Pandas is built on top of NumPy, same way Seaborn is built on top of Matplotlib. It gives you a high level interface. Basically, it's more human readable. That's what this means, right? It's more human readable, and you can create very nice visualizations in a more easier way. So that's kind of why Seaborn is a very popular library. So one thing to understand, I think I mentioned this in Pandas also. When you import Pandas, NumPy is imported in backend automatically. Same way, when you import Seaborn, Matplotlib is also imported in the backend automatically. But typically, we import NumPy and Matplotlib separately anyway, because there are some things here and there which we may want to tweak using the original library. So somewhere I may want to use NumPy, so np dot. Somewhere I may want to use plt dot, that is Matplotlib. So if you're doing quick visualizations for 5-10 minutes, then you can just import Seaborn and get it over with. But if you're doing a much larger analysis, then typically these four things are always imported together. Okay, NumPy, Pandas, Matplotlib, Seaborn. These four things are typically imported together, which is what I'm doing here. But the main thing is this one. The new thing you're seeing here is Seaborn. And it's imported as SNS. Now there's a weird story behind this SNS. Why not something else? You can read it in your free time. Okay. And this is something that I think I'm going to start using. Okay. So after a point, I think we all understand that, look, warnings are going to come. As long as I can understand that my result, looks the way I expected it to be, then I know that my code is working, right? So I don't need a warning each time if I didn't specify data type of a parameter or something, right? So if there's an error, it will be clear for us. I think we are at that stage. So this code here basically suppresses things like version difference warning, whatever. So warning means what? Anyway, you'll get the output, right? Error is the thing we should be worried about, right? It's not executing. Warning means it's executing. So we are at a point where we can see the output and say, is it correct or not? So I'm going to, filter the warnings. So let's run this cell now. Okay. Import numpys, and those who have not installed Seaborn, please install Seaborn. Okay. Run it, and I'm just putting the pip command. You can use conda, you can use pip, anything. Okay. Please install Seaborn if it's not installed. In a separate cell, you can just do pip install Seaborn. Okay. So before we start using this, we need to load our data. So let's go ahead and load this. We know this. This is basically the car prices data from last time. Now this is the original car prices. So there are no missing values. There are no corrupt values, things like that. That's not there in this. Okay. So we will be using this directly. Let's start with quiz number 1. So I need everybody to do this, right? Please load buffet details extended CSV into QDF and use room as index column, and separately load Amazon stocks data CSV into another data frame AMZN. Kindly do these to check the data, like just see if it is there. You can use .head, .info, whatever. Please load both in the right variable names as specified in the quiz, and confirm in the chat when you're done. And if anyone's joining late, I'm sharing the link again to the drive folder. Okay, I also need to load. After loading, please give the command so that I can copy and load. I'm using Jupyter, so someone who's using Jupyter can give me the command. Thank you. Thanks, Abhishek. QDF equal to PD read CSV, index call equal to room. Yes, that is correct. AMZN equal to PD read CSV. Okay, fine. So if you want to see what these look like, you can go ahead and see QDF.head, right? You want to see the other one. So notice that there is an additional column called block. And if you actually want to check info, that is best, by the way. Info is the best. You have 100 rows going from A1 to B50. These are room numbers. And then you have these features. Okay. We'll come to this later. Similarly, let me look at Amazon info, AMZN, 3019 entries. And I think this is where things start to get more interesting in real, right? Why do we do all this data analysis and visualization and all? So that I can handle many thousands of entries. That's the answer, right? So this thing has 3019 entries, basically date, I think. So these are stock price values. Every day your stock is going to have open value, close value. See, open, close, high value, low value, right? So it's been counted for 3019 days. That's a few years. We can see that later. First part, we will revisit familiar graphs. Then maybe we'll take a short break, and then we'll go for some new graphs. Okay. So let's revisit some familiar graphs and see the Seaborn commands for this. Okay, very simple. So for example, we already saw count plot before. If you remember Matplotlib, there was no such thing as a count plot, right? It was plt.bar, and then you have to choose the y value, whether it is count or mean or whatever it is, you have to choose. Seaborn goes one step further and says, don't worry, just do count plot. So you have a direct command called sns.countplot. Okay, this one. So suppose the question is how many cars of each car body type are present in the car prices data set. Car body type being sedan, wagon, hatchback, all of that, right? So it's categorical. So basically it's a bar with y value equal to count, right? For that, if you remember in Matplotlib, what did we do? We found value count, this, that, all that, correct? You don't need to do all that here. So Seaborn directly takes the data frame and takes the variable from the data frame. So if you see the command here, sns.countplot, data equal to df, x equal to car body. So basically this is my data that I want to show. So df, this is my data, and this is my feature, car body, correct? So I'm saying create a count plot of car body feature from this data frame. Everything else is PLT. Okay. So the only reason that I imported matplotlib.pyplot as PLT here is because I want some of those PLT functionality. SNS does not give you that kind of editing and backend functionality. So these things, title, X label, figure, they are all easier to tweak if you use PLT. Okay. So these are just, simple, what you say, just labels and things like that, right? So here you don't need to do much of processing. Directly you can feed the data. So let me just run this. So all of this, title, label, all of this we know. So as you can see, it took the data directly and it took the feature directly. It counted everything by itself and it created the plot. So basically in Matplotlib, we had multiple steps to achieve this. In Seaborn, one command actually will do. So you can, comment out all this, and if you're doing quick analysis, it will directly give you the labels and everything. Yeah. Yeah. So I will be repeating anyway, honey, like same concepts, right by now. I will definitely keep repeating throughout the example. So don't worry, you will not miss anything. Just run, you will follow. Just run the executing commands. The only the only thing that I should repeat here is what? This one. This is the only thing that we need to understand. In Matplotlib allows you to create art. It does not do data processing. That's the point. Seaborn combines data processing and the visualization. So here, instead of PLT bar, and in PLT bar, if you remember, we had to do value count separately and then feed the value counts and the index and everything separately, correct? You remember that everything was separate. Index was separate, value was separate. Those two things came from where? Came from df dot value count. So we had to do data processing there, then give the index and value, all of that to Matplot, just for a simple count plot. In Seaborn, everything is one line. SNS dot count plot, data is data frame. So basically I'm telling Seaborn, create a count plot of my car body feature from this data frame df. So this one line, if you execute, you will get this. Just imagine the speed. Right, just imagine the speed here. And this other stuff you don't need. If you're doing quick analysis, you don't need all this other stuff, title, label, all that is just artistic stuff, right? So if you're doing a nice visualization report, then yes, we will, do all this tweaking and all that. But Seaborn itself will give you multiple parameters within the method also. We will come to that one by one. Okay. Anyway, so this is what my count plot looks like, and we know sedan is the highest count. It has like 85 cars, and then hatchback has around 65 cars, so on and so forth. Correct? Now, if you want to change the order, for example, I might think, okay, see, I want this in ascending order, descending order, or something like that. So here, if you see, I've given a parameter called order. So you can specify order to change this ordering. And I'm just showing one parameter. Slowly we will look at all the different parameters. There are way too many as usual. For example, if I just open up the parameters here, look here, hue order, orient, color, palette, saturation, width, dodge. You have all sorts of parameters. Okay. And double star keyword arguments. This actually means whatever arguments are there from the parent, which is Matplotlib, that also will work here. So basically there are lots of parameters. We will explore some of the important ones example by example. So here what am I doing? Order equal to df car body value counts index. What does df car body value counts do? It will sort the what will do? It will find the values, the counts of each of the car body, and it will print it in a ascending format. Correct? Sorry, descending format. So 96, 70, 25. So from this I can just take the index, which is what I've done here. And if you specify the order as a list, and what is index? Index is nothing but a list. So if you specify this index here, then the sorted graph is what you will get. There's another thing I have done here, right? It has become horizontal. Why? See here, I changed x to y. Previously here I wrote x equal to car body. Here I am writing y equal to car body. So in Matplotlib, it was new function, plt dot bar h, correct? In Seaborn, it's not like that. Seaborn, you just need to change x to y. That's all. And it will, change the orientation to horizontal. So since I've changed it to horizontal, of course, I need to be sure what is my x label, y label. So previously x label was car body type. Of course, now x label should be count because you're showing it horizontal. Now, reason I'm showing horizontally because these names, it doesn't look so good here. It looks okay, but this looks much neater. Sedan is on the top, hatchback is here, wagon is here. Now I hope what you're seeing in front of you, right? This looks like the visualizations that you see on the internet and the applications, right? It's starting to look like that. So this is what I'm trying to say, right? So it's very simple. In count plot, X if you use, you will get the counts of each category vertically. If you use Y, you will get it horizontally. You can specify order. Now you can even specify any order that you want, right? So if I just copy paste this into a new cell, okay, and here I've written, value count index, which gives me descending. I can specify my own order also. So if I am interested in wagon, then I'm interested in hard top, then I'm interested in hatchback, then I'm interested in sedan, okay, and then I'm interested in convertible. So I can give my own ordering here, and it will give me in that order. Okay, so that was a count plot, okay, in Seaborn. Now suppose the question is, how is the count of cars, that is how many cars, distributed across different car body types. Till here it's the same, right? So this question till here it's the same as this, right? Count how many count of cars across different car body type split over number of doors. If you remember, we did this two double bar plot where there were two bar plots, correct? And each bar plot was for a separate number of doors. Now door number, if you remember, I think 2 and 4, these are the two values. So it's a bar plot of the count of the types of cars but split across door number. In other words, how many 2-door cars are sedan, how many 4-door cars are convertible, that kind of a question we are answering. And if you remember, in Matplotlib we did immense amount of code, right? There was almost 10 to 15 lines. Honestly, in Seaborn, I'm just going to comment all this and I'm just going to print this and you are directly going to get what you're looking for. As you can see, one single line. Okay, let me walk you through this. Again, it is sns.countplot, data is data frame. Why is car body? Because I am preferring horizontal. You may do as you wish. Hue, this is the interesting parameter. So hue actually splits the graph into multiple graphs. So if I don't have this hue parameter, let's say I just delete this hue parameter, okay, then you will not get. Then you will get all. So if you see the frequency of sedan, here it is 90. All 90 are here in the blue one, correct? So it's same as the previous. So you see sedan, all the red one, this is at 90, correct? So if I just put this hue parameter, it and hue, by the way, it takes in a categorical. So door number is a categorical, right? This hue parameter will split my bar graph into two bar graphs, or two or more than two, by the way. So door number has only 2 levels, which is why you're getting 2 split. So everything else is the same. Okay, order is this, y is this, data is this, and all of this is quality of life. You know, title, label, you know, all of this is quality of life. So I don't even need these things. I just need to enter this, and as you can see directly, it will you know split the bar graph into 2, and it will also generate legend automatically, and it will also place the legend in the best location automatically, basically. So it does all of this in one statement. So this stuff, the PLT stuff, I usually like to do just to, you know, make my output clean and neat. Little bit, not that different, just a little bit neater and cleaner, right? So the stuff that we did in, you know, multiple statements and all that, we are able to do it in just one state. Okay, so this answers the question: how is the count of cars distributed across different car body types split over number of doors? And this immediately tells me, for example, that there are no 2-door wagons, right? This immediately tells me there are no 2-door wagon cars, there are no 4-door convertibles, there are no 4-door hardtops. The most common type of car is 4-door sedan, Maruti Suzuki Swift, right? The second most common is 2-door hatchback. That is very surprising. I don't know what a hatchback is, but the second most common is obviously whatever this is, right? So it's starting to give you more insights, and you're getting that in one single statement. All right, let's move on to bar graph. So you saw count plot, and we understood that it's essentially a special case of a bar graph where you're counting, and SNS, that is Seaborn, gives you a function specifically for that. In one statement you can get any type of count plot that you want. Let's move to bar graph. What is the average engine size for each car body type in the car prices dataset? So basically question is, for each of these hatchback, sedan, wagon, hardtop, what is the average engine size? Okay. So if you remember Matplotlib, you had to do df.groupby.mean and all of that. Then you stored the output in a series. Then you took the series values and series index and put it in Matplotlib. Nothing like that here. Let me just comment all these other things. sns.barplot, my data is data frame df. I am doing horizontal, so y equal to car body, x equal to engine size. So if you are doing typically, you know, x, what would be the x-axis? X would be categorical. So if you want your bars to be vertical, then x will be your categorical, which is car body. I want horizontal. So I've just switched x and y. It's that easy, by the way. If you want horizontal versus vertical, you just need to switch x and y. So, okay. How we get to know figure? You just try it out. So default figure size, I think it is, I don't remember exactly, but 6.2, 5.2, I don't remember. Please check it, okay? But typically, for example, I'll just print this. See, this is slightly bigger. My 6,4 is making little smaller. So I think it is 8.6 or 7.5, 6.5 something. You can check it in the documentation, honey. And all of us should start making that habit, okay? We should start going to the documentations. We should start asking ChatGPT these kinds of questions, okay? There is some kind of default. And by the way I do it is, I will just make it 16 and see what happens. Okay, so experimentation is very important. At the same time, you can also, and studying documentation is also important. Chat GPT should be for support. GPT should be for, this is my opinion. GPT should be for support. Okay. Documentation definitely you should read. As I was saying, it's again a single one-liner. Data equal to data frame. What is the question I'm trying to answer? What is the average engine size of each car body type? So typically, I would, this is what anybody would do as a first step, right? I would do X equal to car body, Y equal to engine size. Means my car body categories will be on the X axis and engine size value will be on the Y axis, right? This is what I would do. Now, if you remember in Matplotlib, what we had to do was group by mean, all that, right? So we group by car body, then we apply mean. So that's how you got the mean engine size for the car body grouping. Here, you just need to put a parameter called estimator. By default, I think estimator is mean. You can check that. You should check the default in your version, but mostly it should be mean. So even if you don't specify this parameter, default is mean. So when you do bar plot and then you give categorical X axis and numerical Y axis or vice versa, it is going to take the mean grouping by default. No need to do df dot group by car body engine size dot apply mean and then get the index and the values and put it in a PLT bar. Not required. SNS dot bar plot, data is data frame, my categorical is car body, my numerical is engine size. I want you to get me mean engine size for all these category for car body. So estimator is mean. Don't worry about this right now. I'll explain. So if I run this, I will get this vertical. So what you're seeing on the y-axis is mean engine size. So convertible cars, the mean engine size is 152 something cc, I guess. For hatchback, it is 115 something. Okay. So I kind of prefer the inverted version here. So I'm just going to do Y and X change. Yeah. So this is how it is. Now, what is this error bar? So by default, the error bar says CI 95. So this is basically a confidence interval thing, which you will learn in more detail when you will do inferential statistics and all. Right now, don't worry. So if I don't use that parameter, you will get this black thing. It's basically saying that the values, the engine size values, are within this confidence range. So when it says mean engine size is, what is this? Convertible is around 155 or something. This black line basically tells you plus minus how much. That is sufficient to understand right now, guys. Don't go deeper into this because the math behind all this you will understand in a later, module or week, which is inferential stats, hypothesis testing, all of that. So if you don't like this black thing, it's just giving you plus minus error. Think of it this way. It's just giving you plus minus error. That's what error bar is. So if you don't like it, you can put error bar is none. Okay. And that gets you the bar plot that you got in Matplotlib. And this is another point. In Matplotlib, you cannot get this default error bar, standard deviation, all of this you cannot get. So here in Seaborn, we are getting everything in one liner. The main thing to remember is what is your data. So this is the main thing to specify from which data frame you want to take. And then you specify what is on your y-axis, what is on your x-axis. The Seaborn is intelligent enough to understand which is categorical, which is numerical, and what type of graph is being produced. Okay. So, yeah. So moving on, here, for example, what have I done? I've done median, and here error bar, I've put standard deviation. This is what I'm talking about. So here, if I just change this, right? So I've changed estimator to median and error bar to SD, standard deviation. So we may remember standard deviation from our high school mathematics, right? It's a measure of variability. It's a measure of how much variance is there, how much variation is there within a variable. So the convertible car's engine size is actually a set of values, correct? It's not just one value. What you are showing on the height that is here, which is around 140 or something, that is the median of all those engine size values of the convertible cars, right? That is the height of this blue bar. The black line is now specified, I have specified as standard deviation. You can specify different kinds of variance measures, which again you will do at a later time. So not to worry too much about that. Since standard deviation is something that we have studied, I have just mentioned here. Okay. Don't worry about all the math, right? So yeah, so we've seen, we recounted count plot, bar plot, and things like that. And, we saw grouped count plot also, I think, and let's look at grouped bar plot. How difficult can it be? And just for this case, I want to recall the object-oriented programming style just to show you that when I said Matplotlib returns object, Seaborn also does return object. The only thing is that, as I told, Seaborn is more user friendly. So what it does is it cuts down a lot of object oriented tweaking. So it cuts down on that. So this is the sort of thing you can do, but I mean, this gives you a little amount of tweaking, but nothing compared to Matplotlib. So this kind of code you might see very less, is what I'm trying to say. You might see this kind of code everywhere. People will use, sns.barplot, sns.countplot, sns. Whatever. People will use it to quickly do all the different data analytics steps. But the slight changes in, things like what should be my X label, title, all of that, most analysts would use PLT. If you still don't want to use PLT, right, then you can do this method wherein the output of your bar plot, so the same thing, right, sns.barplot, this whole thing, the output of your bar plot, you can actually store it in a variable, right? So as I said, this is just the display of the object. The actual object is here. Then the object has methods associated with it, just like pandas, data frame, series, or whatever, right? So this Seaborn object has various commands. So here I have set X label, set Y label, set title. This should now remind you of Matplotlib, correct? So it's essentially following that approach. And again, as I said, I don't necessarily use this all the time. I have not seen analysts and data scientists using this kind of method all the time. It's just I'm showing it to say that, look, it's there. And in case this is not able to satisfy your requirement, which is very unlikely, okay, Seaborn and Matplotlib slight tweaking of the graphs using Matplotlib is more than sufficient, which is the scripting method. You don't necessarily need the object method, but I'm just showing you. Okay, so in this case, we are doing a grouped bar graph. What is the question? How does the engine size vary across different car body categories split over number of doors? So basically, this is the variation in engine size, average engine size, based on the car body type. Okay. How does the engine size vary across different car body type? Okay. Split over number of doors. So just think back to countplot. I think everybody can guess what we need to do here. Again, the hue parameter is going to split the graph into n number of parts. Depends on the number of levels or number of unique categories in the categorical variable that you're using here. So here I'm doing the same thing, sns.barplot. My data is data frame. I like horizontal. You may switch it if you want. Y is car body, X is engine size, hue is door number. So I want to split the bar graph through door number, and then I want to estimate the engine size averages by mean. And notice, guys, that estimator is applying mean on engine size only. So if I put here X and here Y, it will still apply estimator mean on engine size. It is not going to apply on car body. Notice. So it's not, as I said, it's smarter than Matplotlib. Otherwise, you might think estimator is always applied on Y value. No, right? If I put Y here and X here, what is mean? Mean is a numerical estimate. That is definitely going to be applied on X now. Why? Because this is numerical. So SNS actually improves all of these features for us. Okay. So let me go ahead and do this. Now I'm storing this in a bar plot variable, and then I'll set the labels and things like that. In Matplotlib, again, remember in Matplotlib, what did we do? I think we spent like so many code lines trying to get the value, this, that, lot of steps were there, right? In this, again, as I said, I can comment out all of this stuff, right? And I'm going to get exactly what I asked in one line. sns.barplot, my data is data frame. I want horizontal, so Y is car body, X is engine size. Now if you see, this is my Y, right? Y is Y axis. This is categorical, and X is engine size. So X here is numerical, 0, 25, 50, 75. And by default, estimator is mean. I don't need to say it. I don't even need to put this. Okay. By default, estimator is mean only. Okay. I'm just putting it to show you guys. And I want to split my bar graph according to the door number, and it generates the legend also. So now looking at this, I can answer this question. How does the engine size vary across different car body categories split over number of doors? Okay. Okay. So basically, 2-door hardtop cars have the biggest engine size, and 4-door hardtop car doesn't exist. Okay. Within sedan, in sedan, 4-door cars have slightly more engine size than 2-door cars. Interesting. But within hatchback, opposite. 2-door hatchbacks have slightly bigger engine size than 4-door hatchbacks. Why is this the case? We have to do it a little bit more analysis and look at the ground reality. So as I said, data analysis is half the job, is 50% of the job. The other 50% is for me to go and investigate this further. So when we say that we are becoming a data analyst or data scientist, that doesn't mean we are fully relying on the maths. No, we are relying on the mathematics, plus we need to rely on the subjective understanding of the domain, what is really happening here. So to further answer this question, we need to learn about cars, or we need to have some expertise on cars, right? So my point is, in your own domain you will be able to answer this question better. So suppose you are a car expert, then you can answer me immediately why there is slight difference in this. And for example, why is the engine size of hatchback bigger in 2-door and smaller in 4-door, but why is the opposite trend visible in sedan? I don't know. A car expert will be able to answer. My point is, data analysis and data visualization takes you to that stage, quickly takes you to that stage. Okay, so that's kind of the power here. Anyway, so this kind of scripting, this kind of code writing is not very common. As I said, I'm just showing you. Typically, this is what you will observe. In fact, if you're looking at very quick, short analysis, you may not even observe these PLTs. Mostly, you may just observe one-liners. Okay, if you're writing a big, nice report, then you want to tweak your visualizations. All right. Right. So finally, I just want to mention Catplot, and here I'm not going to spend too much time. I want you guys to explore this on your own. I'm giving you one example. So Catplot means categorical plot, right? And it can plot different kinds of categorical. So if I just see here, there is this thing called kind. Okay, so there's this parameter called kind. Now in kind, I can specify strip, swarm, box, violin. So violin plot is another famous plot. I don't think I'll be covering it today, but feel free to explore violin plot. Okay, box plot I will be covering it today. Bar we have done, count we have done, and there are other types of plot. So cat plot is a universal categorical plotting function basically. So if I'm using cat plot, again, same thing, data is df, y is car body, x is engine size, and all of that. But here you have to specify what kind of categorical plot are you talking about. Bar plot, box plot, this, that, right? So kind equal to bar. And here instead of hue, you will be using call. So it performs the same function as hue. So if you go here, you will see call equal to none. And here if I go down to the documentation, it says, where is call? Here. Row call, names of the variables in data, categorical variables that will determine the faceting of the grid. So the word faceting may look very confusing. Faceting just means how to divide. That's all. So this and so these three are basically telling my plot how to divide the data. Okay, and everything else is same. Estimator is mean, error bar is none, so on and so forth. And here you can actually again set axis labels and get a super title for the graph also. And here the y equal to 1.02 is basically a positional argument. So if I just do, for example, 2.02, it will create a lot of space between the title and the graph. So there are many of these, as I said, small tweaks, which I think it's better if you keep exploring and debugging and find out. There are just way too many to cover, right? So what I can do for you is I can show you that this is how it works, and these are some of the examples. So categorical plot, it is useful sometimes if you're doing more detailed analysis. Sure, feel free to explore this a little further. I think we are all in a position where we can do that, right? Okay, so what is this categorical plot answering? Let's at least discuss that. What is this? It is answering the same question, right? Average engine size by car body type split over number of doors. That's exactly what it's answering. But it is now dividing into two graphs. So basically a kind of subplot, right? So here door number equal to 2. This is my one column. So call equal door number. This is one feature in that, door number equal to 2 and door number equal to 4. So basically the same information has been split here, okay, left and right. And if you remember, one thing to notice is that the Y label is actually common for both. So this is slightly more advanced. What I'm trying to say is this is slightly more advanced. I think that you guys will be better at exploring once we, finish all of this and you start, exploring this. I think more than capable that we can do that. So there's a link here. Feel free to look at the documentation and some examples and things like that. Okay. All right. Now we also remember stacking. So this is called grouping, by the way. So this is called grouping, right? When you shift it horizontally, it is called grouping. I'm using the word horizontal, but my graph is tilted this way, so don't get confused. We typically use, X and Y like this, right? So now you can say, okay, this is actually grouped horizontally, right? What is stacking? Stacking is one on top of each other. So let's see an example of that, right? So how does engine size vary across different car body types, split over number of doors, right? Same thing, same question as before, but we can do this by stacking also. And before I do stacking, if you remember last time we did something called cross table, and I hope you guys went ahead and explored that method. It's a pandas method, obviously. Cross table gives you frequencies. So it basically takes categorical in row dimension, categorical in column dimension, and it will find intersection of the two categories and see how many such entries are there in the data frame. Pivot table, and this again you will do in more detail in exploratory data analysis. Pivot table is the generalization of cross tab. So just like bar plot is the generalization of count plot, same way pivot table is the generalization of cross table. So cross table gives you count, pivot table will give you anything. So here pivot table is giving me mean engine size. See the thing I have highlighted. So my value in the pivot table is engine size, aggregate function is mean. In other words, use index as car body, use column as door number. So whatever my output is going to be, index will be car body, columns will be door number. Then the question is, what is car body, door number? Suppose car body is sedan, right? And door number is 2. So then what this is going to do, it's going to find the mean engine size of 2-door sedan. Like that, it's going to find the mean for all the different possible combinations. So the cross table was just giving me count, which is what a stacked or a grouped count plot is doing. Okay. Where is a grouped count plot? I think we did one somewhere. Yeah, this. So this is a grouped count plot. So this is exactly the visualization of the cross table, nothing else. Whatever you saw in the cross table numerically, you are seeing here visually. Same. Absolutely no difference in information, right? It's just two different ways of showing it. One is numbers and a table. One is visualization. Same way when let's execute this. So here see 2-door sedan, average engine size is 127.3. 4-door hard top is 0. Why is it 0? Because I put fill value 0. In fact, let me delete this and show first. Okay, nan. Nan means what? Doesn't exist. So you can actually check this with your count plot also. If you go back here to the grouped count plot, where is it? So there are no 2-door wagons. There are no 4-door hard tops. There are no 4-door convertibles, which is why you're getting nan here in the pivot table. Where is that? This way you're getting these nans, 3 nans in the pivot table. Nan doesn't look good. So you can use a fill value for that. So wherever it is not finding any data, you can fill 0. Okay, which makes sense. If there is nothing there, then the engine size is 0 because engine doesn't exist. Okay. So I hope you understood that. So cross table, count plot, pivot table, bar. Okay. And yeah. So now I want to just talk about one small thing which we missed. I wouldn't say we missed last time, but more like we were talking about a lot of things, so I did want to mention it, but I didn't want to disturb the flow of the session. Let me mention it today. So pandas objects have a built-in method called plot, right? So there's another way of plot. This is also very common. So when you read your additional articles, when you try to debug your code and you're seeing different articles on the web, things like that, right? You will find this method also. This is quite common, right? So what's happening? Pivot df dot plot. So the dot plot method is applied on the data frame. So you can actually use it on a series. You can use it on data frame also. So if you want to check that, please check documentation of pandas plot. Just Google panda plot, pandas plot. There it will show pandas.dataframe.plot, and of course it will work for series also. Okay. So it's an inbuilt method, just like mean, group by, all of these, right? Inbuilt method of the object, pandas object, same way dot plot exists. Okay, so it's using an inbuilt plotter. In fact, I should comment all this and show you. So this is my data frame. We all agree this is a data frame, right? This pivot df, if you see the output, it is a data frame, correct? So it has index, it has column, it has values. Clearly this is a data frame. On this data frame, I am doing plot, and then here again you have certain parameters. So kind will tell you the type of plot, and then how you want to visualize it, stacked equal to true, false, so on and so forth. So in one line again I can do this pivot df dot plot, kind equal to bar, stacked equal to true. Now it's going to stack up and down. Now suppose if I say stacked equal to false, it is giving me group. So if I do stacked equal to true, it will give me stack. it is, if I do stack equal to false, it gives me grouped, right? So this method is quite common, but it may be limited in its approach sometimes. If you're doing slightly more complex visualizations, I would recommend Seaborn, because in this you have to apply the visualization on the object, correct? Now what if you're dealing with multiple variables, multiple objects, and you want to create a nice what you say, nice sort of complicated plot but easy to understand plot? In that case, this is not easiest. This kind of method is easy to quickly look at some variable. Basically, just wanted to put it out there that it's there. This method also exists, so you can feel free to use this method as well. Okay, so in fact, if I just say, for example, df, suppose I say price, right? Do I have price? Yeah, I have price. So this is a series dot plot, suppose kind equal to hist, I think. Is it no, it gave me the histogram, right? So I took a series from my original data frame price, which is a numerical variable. I just did dot plot. I said kind equal to hist. Okay, it gave me a histogram of the what do you call the feature. It gave me a histogram of price, right? So this method does exist. As you can use whichever ones you feel like using. Obviously, Seaborn is something that you want to use for more difficult analysis. The pandas dot plot method you can use to quickly get to see some variable to understand it, and Matplotlib you want to use to tweak how your plots look, and you can change font size, spacing, all those kinds of things. Okay. Anyway, so if I do this pivot df, this data frame dot plot kind equal to bar, and let me do stacked equal to true, because we have been seeing this for a while. Group, let's look at stack. So stacked also has its advantage and disadvantage, right? So it gives you like comparison in a different way, that's all, right? So here I will say, okay, these two look almost the same. Here I'll say these two look almost the same. Now it looks neater, but this gives me more information. Here you can see there is a slight difference here, right, in the engine sizes of hatchback, 2-door, 4-door. Similarly for sedan, very slight difference. That kind of difference, it's not very easy to see in stacked, but this is slightly better looking in a sense, right? So again, choose which plot you want and for what reason you want to show. I think we already did rotation. So this is a matplotlib command, xticks rotation. So here we did last time 45. You can do whatever. In fact, 0 is also fine. Yeah, 0 is also fine. I don't need 45 here, which means I don't need this. Yeah. So, oh, okay. Sorry. Yeah, that's the reason. Yeah. Okay. So yeah, here it is horizontal now because rotation is 0. Yeah. So this is one kind of plotting. Now, if you want, so this is vertical, obviously. If you want this horizontal, which typically I try to follow horizontal in case my categorical names are big, convertible, hardtop, hatchback, then you can select kind as bar h. Okay. So what you need to remember and what you need to understand is that for all of these different kinds of methods, parameter names may keep changing, and this is something that I deal with and everyone else deals with also. And I think yesterday or day before, sorry, one of you Abhishek was asking, I think, do you remember all the parameters? No, I absolutely do not remember all the parameters. Okay. If they had at least kept all the parameters same throughout all these different methods, maybe I would have tried, but it's not. So that is something that we have to sort of, make peace with. I don't use it so commonly. A lot of people do. For me, I've just become very used to using Seaborn directly. So I typically what I do is I just use this, not even this. I use this. Yeah, I just use this. So because I've used Seaborn so much, but there are still people who will use Matplotlib a lot and Seaborn less. It's all preference. But I mean, if you're a user and you want to use this tool to make yourself more productive, I would recommend directly use the Seaborn commands. Okay. Anyway, so if I do kind equal to bar, this is making it horizontal, so on and so forth. Okay. We also remember line plot from last time. I think we did air passengers or something, correct? So let us see for a different data set. No, this I think we already loaded. So let me just load it again. Question is, and this is a stocks data. So here, if you see, it's basically Amazon stocks, and it has dates. Okay. And basically it's giving me the open value, which means the value of the stock when the day starts, and then high value, which is the highest value of the day, low value is the lowest value of the day, close value is when the day ends, what was the stock value, and how many stocks were traded. So volume is obviously 7, 5, 8, 2, and 2, 7. These many stocks were traded on that day. So this is basically, financial data, stocks data, and this is a very large data set, guys. So there is a reason that I put range here. Okay, so if you don't put this range, this cell will take a lot of time to run. Okay, which is why I put a range here. In the sense X ticks. Okay, it will show all the data, but X tick I'm not showing all the dates. Obviously, there are 3020 dates or something. Okay, so I cannot show all those on my x-axis. Anyway, so the command is sns.lineplot. Now I'm not going to comment and run. Why? Because my x ticks will go crazy because the number of data here is way too much, right? So it will take a while to run. Maybe about 25-30 seconds. I don't want to do that right now. You can do and try. But the main thing you should be looking at is this. So see how simple it is. SNS equal to line plot. Data is Amazon. X is date. Y is open. That's it. And X ticks I have just arranged in such a way. And these are obviously LOC indices from here. 0, 1, 2. You can see these, right? LOC indices. These are obviously LOC indices. Okay. So X ticks I'm just giving it in some intervals. So otherwise my x-axis label will become, I can't read anything, right? Full black it will be. So it's just a one-liner here, and still see it's taking some time to run. It took me 8 seconds to run with this because what you're seeing here is 3000 something data points. Okay, these are around 3000 data points. So here you can see these are the dates. So 2004, 2007, 2008, 2009, 10, so on and so forth. Why don't you not use rotation and check? Okay, and here if you check the actual data, range index, what does it say? It says 3019 entries starting from 0 to 3018. So if I don't specify this, I'm going to get completely black here. Okay, so this is the xticks command from Matplotlib. So here what it's doing, it's starting from 0, going till the end, right? But in steps of 302. So it is skipping 302 values in this LOC. So if I just, let's say, I'll just print AMZ. Wait, let me just print AMZN directly. So here you can see 0, 1, 2, 3, 4 till where? 3018. So do you think I can show the date labels for 3019 entries here? No. So if I don't specify my xticks, so xtick 030193002 means what? Range means what? This produces a list, right? It produces 0, and then next will be 302, next will be 604. So what is 302? Just check amzn.loc 302. This is the date 2007 319, and rotation is right now bad. Let me just show you. So the second entry should be that. See, 2007 319. Can you see 2007 319? That is what is here. What is this one going to be? This is going to be 604. What is this? 2008 529. So if I just put here LOC 604, date 2008 529. And why is it showing me date on the x-axis? Because that is what I specified here. X equal to date. Making sense? Okay, great. Right, yeah. So line plot also can be done using SNS in one command. Just be careful with the size of the data. Okay, very simple. The only difference is we need to include a label parameter. If you don't include this, I'll show you what happens if you don't include. So suppose I don't include, because these are two different SNS plots. Okay, so here I have SNS line plot, SNS line plot. I have two different values, so I cannot put both values here as a list. Okay, so and suppose legend I'm going to comment out. Now if I print this, what is going to happen? It's going to throw two plots on the same figure. Semicolon. Basically it's going to throw two plots on the same figure, and both are line plots. But if you see the Y values, one is open, one is close. So opening stock price, closing stock. Now I can see there is little bit blue orange. So obviously the first one is blue, second one is orange. We already saw this last time, defaults, right? But where is the legend? Where is the label? Even if I do suppose PLT legend, right? It's going to throw an error, and let us wait for the error. No artist with label found to put in legend. So we have to put the label. So when you are using two different plot commands, you should put the labels, which is what I put here. Okay. So for open, my label is open price. For close, my label is close price. Both are line plots. So now I'm going to look at how open and close price are varying. Again, careful with the xticks so that your graph looks readable. What is the question here again? How have the stock prices of Amazon varied over the years? Okay. Clearly it has increased. That much is obvious. From 2006 to 2016, this is almost what, $10, right? Obviously this is in dollars. What is this? Not 10, but 100, around $50-$60, right? Beginning of 2006. The same thing in 2016-17 is almost $1,200 per stock. Just look at the increase in the stock. Okay. And yeah, here is my other graph. So the open and close price are more or less the same. Now you are looking at 3000 data points, so maybe you want to do a bit more pinpoint analysis. So why don't we subset it? So let me subset from the first 100 values or something. So which is what I'm doing here, right? I'm subsetting Amazon, the Amazon data frame for the first 100 values. Okay. And instead of AMZN, let me use sub AMZN. Okay. And everything else is the same. So this shows you slightly more pinpoint trends. So here, for example, there's a dip in the open price here. Like this seems to be what? This is 2006. 10th January. I don't know what happened in 2006 10th January, but the open price dipped, the closing price was okay. So this is indicating something like, when it opened, there was a bit of doubt on Amazon, some problem was happening, public perception issue, something may be there, which is why there was a dip, right? And by the end of the day, they solved the problem. Amazon solved the problem. So the closing price is fine. So you can see slightly more detailed things. Like here again, there's a dip. This is a pattern. In fact, if you see this pattern 2-3 times, Amazon should go and check why this is happening, right? So again, power of data analysis, right? So you can clearly see dip here, similar dip here. Why is this happening again and again? So Amazon should go back and check. And again, are we like solving the same problem again and again? So there was some problem in Amazon on January 10th, which obviously head of Amazon not going to solve, right? Somebody in some team would solve the problem, and then the closing price came up again. Similarly here, this seems to be what, February end or something. So ending of February, again there's a dip. So again there's a maybe a smaller team has solved the problem, but the upper management has to look at this and think, hey, this is repeating pattern, what's happening, right? So again, this is the power of data analysis here. Yeah, so that's something that I wanted to show. In fact, I think we have started answering this. Now, to answer this question fully, it's going to take a very big analysis. Okay, so as I said, this is a larger data set with many questions. So this question is also not very specific. How have the stock prices of Amazon varied over there? It's a very generic question. Again, I know, see, I'm sort of teaching and training here, so I'm using some kinds of questions, but most of the questions look good. This one is very generic, so I think that it should be more pinpoint. Like actually, if you're doing this kind of analysis, the question should be more pinpoint, should be more precise. It shouldn't be how have the stock prices of Amazon varied over the years. That is something news article, that kind of thing, right? Like if you're really doing an analysis, you may want to ask a question like, how has the mean closing price per month of Amazon varied in the holiday months over the years? So this is a very, very, very precise question. Getting what I'm saying? Now with this precise question, you should go and do everything. Pandas, Matplotlib, Seaborn, whatever. Use whatever tools you have at your disposal, answer my question, correct? So that is the job of data analysis. So try that, okay? On the spot, I've given you a very precise question. So try this, try my question using whatever you learned. Anyway, so I think finally histogram is something that we saw last time. Let us again look at it in Seaborn. What is distribution of car prices in the car price data set? Yeah. So this obviously histogram is best. Distribution of numerical data, right? Histogram is the best. Here the method is histplot. Okay. So sns.histplot. Just specify the data frame and the variable. There's only one variable in histogram, which is the x-axis. Y-axis is actually count. Okay. So you just need to specify the variable. Yeah, we have already seen this before. We know this. We've seen this before. What else can you do? I told you that we can change the number of bins, right? So here it's default, bins from Seaborn. You can reduce the bins to 10. You can reduce it to 3, 5, whatever. Okay. So what is this telling me basically? It's telling me that most of my cars are around $5,000 to $12,000, right? That's what it is telling me, right? It's telling me how the prices are distributed in the market, basically. And this is somewhat semi-obvious, I would say. Like cars around 40,000, 45,000 are very rare. Okay, that's an obvious state, but this is not that obvious, right? So here 50,000 to 12,000 we have so many cars, and 12,000 to 22,000 we have so many cars. This I think will depend on the different kind of market. It may depend on the city, country, market conditions, so many things, right? So for this specific data, and I think this is some data from the US, the car prices, don't quote me on that, but I don't think this is from, I think this is from some sort of university or something from US, right? So there in that market condition, it seems that the lower the price, there are more cars. So you are seeing this kind of an exponential decrease. So we might be tempted to call this a exponentially decreasing curve. Regardless, so you can change the bin size based on the type of output you want. So if you have more bin size, then you're actually looking at very small intervals and saying this is my price range, this is my price range, things like that. Depends how many bins do you want, or what is the size of the price range you want. This is what it depends on. So if you want 30 bins, you can do that also. So this is very pinpoint analysis. This is very rare, right? If you're doing a sort of analysis report and you are the one designing these cars, maybe you will use these many bins. But if you're somebody who's trying to sell the cars, maybe you're in the sales teams and all, then you may use less bins, right? That kind of thing. And again, obviously you have all these other parameters, you have color and everything else. I do urge everyone to open the documentation and check everything. Okay, there are many parameters, no need to use all the parameters. Okay, not at all. It is all incremental learning. We should first learn all the basics and then little bit advanced, and then other things it will come to us. Okay. Color, linen, there are many colors, by the way. And I found a very interesting method. If I just say color is haha, it'll tell me, I think, okay, it's not telling me. Too bad. So some of the methods will actually give me the, values that are allowed. So this one is not giving. I think palette, when you do palette and you give a wrong value, it will give you some sample palette values. So color it's not giving because I think it's obvious. Color is red, blue, green, yellow, whatever, right? So there are some very exotic colors like linen, things like that. Okay, but you can explore that on your own. All right. Now this is kind of telling me how the car price distribution is varying. I don't like so many bins. I'll go with 5. Okay. So this is telling me how it is. The prices are varying, which means around 125 cars. You can see the y-axis. These are low price. Around only 5 cars are high price. Medium price also not so many, right? So if I say this is sort of the mid range, it's still much less compared to the low price economy. Okay. Now if I ask the question, what is the distribution of prices for cars split over car body type? Okay. So same histogram, but now I want to know, how about the distribution of prices for different car body type, right? And if you remember, I think we did, a split histogram for this, but the commands and code are so difficult. In Seaborn, as you may have guessed already, just use hue equal to car body. And here I'm using multiple equal to stack. I believe if I do not use that, I will get overlap. So you can see a convertible, hatchback, sedan, wagon, hardtop. They are all one on top of each other. It is hard to understand this, right? So it is very hard to understand the default. Default is overlap in histogram. So here I may want to use stacking. So the parameter to do that is multiple. So I do that, right? Again, all this is same. Look, data is data frame, X is price, hue is car body, and multiple is stack. Okay. So now it stacks. What amazing, visualization this is. Let's just take a moment to appreciate this. Just see. What it is telling me is the higher the price range of the car, the lower the presence of hatchbacks. First thing that appears to me. So here you see so many hatchbacks, orange color, so many. But the later you go into the price range, I am seeing very less hatchbacks. Immediately it says the higher the price range, the less the hatchbacks. Why? Is it difficult to make high range hatchbacks? What is the problem? So as you can see, data visualization analysis, it brings out all of these facts, all of these insights from the data. Immediate, what a beautiful visualization. Just look at it. You can see the insight. That's the whole point. You can see that insight here. Numerically, what I have to do, I have to look at the pivot table and all of those other things, right? And in fact, this is numerical data, even harder to analyze. In a visualization, so easy. And even wagon, see wagon type, you can see there are a few wagons here in the lower range, but absolutely no wagons later. Which are the only cars that are going into higher range? Sedan, convertible, hardtop. Why? What is the reason? So the visualization has brought, so I don't know anything about cars and data. I applied data analysis visualization. Now I know something. I can see the facts more clearly. If I do little bit more research into the actual domain knowledge, then I can answer questions much better than, much better. Make sense? So yeah, I mean, this visualization is just really nice. Anyways, again, so here, for example, I'm showing you the effect of palette. So here my default palette is working, guys. If your default palette is not working, just use tab 10 or something. Here I'm showing you some other palettes, just for to show things that are there. There are a lot of palettes to use. Muted is one of the ones that I like because it's a little bit dull color. This is a little bright. You can choose whichever you like. And as I said, if I don't put palette, suppose I put haha. Okay, even this method is not giving me. Maybe it's a version thing or something, but there are certain methods which actually suggest a method. Okay, this guy is not suggesting. Anyway, if you remember, I gave you the link. Let me give that link again. Here is the link to the color palette documentation in Seaborn. Okay. In data, we don't have to define y. Where? Histogram. Why would you define y in histogram? Histogram by definition means counting the number of values of the variable. The only thing you need to define is the variable. So in this case, what is my variable? What is my variable actually? Price. Price is my variable. So histogram does nothing but it brackets the prices into buckets and then it counts. How many prices fall here? How many prices fall here? How many prices fall here? That counting is part of definition of histogram. You don't need to define that. Okay. Anyway, so this palette equal to dark. By the way, guys, some methods, yeah, sure, honey, no problem. Some methods will give me, suggested palette. It's not giving me right now. But anyway, not a big deal. Documentation is there. You can check various palettes available. Dark. This is muted. There are many. I think it's best left to you guys. Like HLS. I don't even know why it's called HLS, but it looks very fluorescent, right? So this also looks nice. This is also nice color palette. Anyway, so this brings me to the end of the revision of the previous visualizations using Seaborn. Please answer this quiz. We will take a very short break because I have a bit more to cover. And as I said, we've been handling a lot of other kinds of doubt. And just split by the block in which guest lives. So first I want to see what is this. Okay, block. So QDF, sorry, block dot unique. What is going on here? A and B. Okay, fine. What is the question? Question is relationship with cuisine. Okay, so now comes the, I think Ankita was asking that question, right? Very valid question. What plot to use, how to practice. This is the way. So if your question is well defined, then definitely you will know what to practice. So here it says, see, what is the relationship between cuisine, categorical, and expenditure, numerical? You think practically, if there is a hotel which is giving 2-3 cuisines, maybe Indian, Chinese, American, and the thing they are interested in, expenditure, how much a customer is buying. If the hotel manager is asking question relationship between cuisine and expenditure, what is the hotel manager asking? Which cuisine is doing better on average, isn't it? And what is the way to answer that? Bar plot, I think, isn't it? And that's what the hint says here. Use a bar plot. Put categorical as cuisine, numerical as expenditure, estimator, mean or median is your choice. I already told you by default mean is okay, no problem. That's all. So let me do that. SNS dot wait, I do have some code here, so let me take the codes and see. PLT figure size equal to 10.6. I don't like this method. You guys are free to use, but yeah, I don't like that. Data is QDF, Y is cuisine, X is hue is block, estimator is mean, error bar is none, palette is tab 10, order is American, Indian, Chinese. Perfect, nice. Yeah, alphabetical order, I think. Okay, right. Forgot my semicolon there. And figure size very big, so I'm going to make it smaller. Okay, so what is the question? Relationship between cuisine is depending on the block. Okay, so this is where a little bit more interesting, right? Clearly, there is no difference between the expenditures on Indian and Chinese cuisine in block A and B. See, block A is blue, block B is orange. So if you see this Indian cuisine, how much expenditure, mean expenditure? Almost the same, isn't it? For block A and B. Chinese also almost the same, but slight difference in American. So block B, people are spending slightly more on American cuisine than block A. So this could tell you about, then you can come up with intervention methods. Okay, block A pantry needs to have more of so and so ingredient, block, those kinds of logistical decisions and all. You are in a better position to take. So rather than somebody saying, Mr. Manager, we are short of this many onions, things like that, right? If you sincerely do your data analysis properly, then running a business will be smoother, right? Yeah, great. So great. Okay, so next is Boxplot. What I'll do, right, I'll take a 5-minute break. Let's continue at 22:50, that is 10:50, which are not meant to be fully understood in 1 hour. or 1.5 hour. Therefore, for example, Boxplot has interquartile range, outliers, all of these things. These topics will also be touched upon and elaborated further in data, exploratory data analysis, data processing, those kinds of things. Okay, I'll give a brief introduction. Similarly, we will also be looking at KDE plots, and the math of KDE plot is out of scope of the program, but I will explain to you what it is doing. Similarly, we'll also be looking at heat maps, and in heat maps, one of the most common metric that we use to visualize as a heat map is something called the correlation coefficient. We may have heard of this in some statistics somewhere. Again, this will be dealt in way more detail when you do bivariate analysis, multivariate analysis, those kinds of things. When you do that, this will be done in more detail. So the frame of mind we should keep for part number 2 here is get a sense of what the numbers are doing. Don't worry too much about the exact numbers and the formula, which you will anyway study later, and try to understand how the plot is making me understand the numbers without understanding the numbers. That's kind of what we did in some of these cases also, right? There's no numbers anywhere, but still I'm understanding all these plots and drawing insights from, right? Especially this plot, right? This one is kind of wow, right? We are not even looking at the numbers, right? The analysis is just visual. So what I'm asking you guys to do is understand the numbers, understand the visualization also, and don't worry too much about the math right now, which anyway we'll be doing later. Okay, so with that, I'm going to start with box plots. So technically speaking, Boxplot is a substitute to histogram in a sense. And if you remember, and if you can see, histograms for different variables, plotting it on the same plot is always going to do things like overlap, stack. It's not. It's good when you are dividing a single variable using a categorical, right? So here the single variable is price, and you're dividing it using these categoricals, and you're looking at it in a certain way. But there are also another method to visualize the distribution, and it gives a different kind of information. So a box plot essentially has these components. Okay, it has a box, it has a line inside the box, whisker, outlier. Now I'm not going to read all this. I will explain in the graph. You can read this later. And basically what it shows is something called quantiles. Okay, so these things, when we see the plot, I will get back to this, so don't worry about this. But the milestones or markers, special locations in the box plot are actually quartiles. Okay, so here if you see, I would have written it somewhere. Quartile. Where is it? Okay, it's not here. Quartile. So quartile is nothing but division of data set. Okay, so we'll see that one by one. Quantiles are basically, it's a way to divide data set. So in a sense, if I just say divide the data set into two parts, the first thing that comes to your mind is median, isn't it? First thing that comes to your mind is median. So if I want to divide data set into two parts, I use median. That is actually a quantile. Median is actually a quantile. Now if I say divide into three parts, you will get two quote unquote medians. I cannot call it median anymore. So median is a special quantile dividing into two parts. If you divide into three parts, you will get two quantiles. Okay. If you divide into three parts, you will get three quantiles. If you divide into five parts, you will get four quantiles. Starting to make sense? So median is a special division of the data set. And we all know how do you divide? You do it in the ascending order or descending order. Correct? So histogram is the best thing to show a division. Okay, so first let's understand quantiles. You can get quantiles using quantile method, and you can also get the quartiles using describe method. Right? So because describe, if you remember df.describe, which I'll show you here, right? So suppose I take median value of city MPG, right? My question is, what is the distribution of city mileage of cars? Again, distribution. So we can use histogram, correct? So before that, let me just find the median of the city MPG, 24 miles per gallon. Okay, now let me do citympg.describe, and again notice df citympg is a series. So again, I've been repeating this from so many sessions. Whatever method you have for data frame will work for series. So here, see, you're describing the series who's having the values of the city MPG values, right? So just check this 50%, 24.000, and check this median value, 24, correct? So it is actually giving you quartiles. So it has divided your data set into 1, 2, 3, 4 parts with 3 values. So there are 3 quartiles. First quartile, second quartile, third quartile. Second quartile is the median. Basically Q2 is the median. So 50%, which is the second quartile, that is the median. It is separating 50-50. First quartile will separate 25-75. That is why you are getting here 25%, 19. The value is 19. So the CTMPG of 19 miles per gallon is up to 25% of the data set. Up to 50% median, second quartile, which is 24. And then up to 75% it is 30. And then up to max it is 49. And minimum is 30. So it has taken your full spread of the CTMPG values and it has cut it into 4 chunks. Quartiles usually are the ones in between, but of course you can include the 0th and the last one also. Those are trivial cases, right? So min and max are the trivial case. There's no need to call it a quartile, but of course it starts with minimum value and maximum value. And then if you're dividing 2 parts, median. If you're dividing 1, 2, 3, 4 parts, then you have quartile, 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 whereas the second quartile is the median. Anyway, I think that's a decent introduction to quantiles. Quantile is the generic term. So you can divide your data set into 7 part, 10 part, 20 part, whatever it is. The generic word used is quantile. Has everyone heard of percentile? Kindly put in the chat. Does everyone know percentile? That's exactly what this is, na? That's exactly what this is. In percentile, you are using 99 quantiles. In percentile, you are using 99 quantiles to divide the data set. Okay, makes sense? Wonderful. So, types of quantiles have their applications. So, percentiles are used in certain cases, quartiles are used in certain cases, so on and so forth. Okay, so now that I know these are my quartile values, see, I am going to plot a histogram of CTMPG. Okay, this is anyway going to answer the question, what is the distribution of CTMPG? So data equal to df, x equal to CTMPG, SNS dot histplot, bins, do whatever you want. I usually like 5 bins. These red lines I have plotted using Matplotlib. Now this is where Matplotlib will help you. These additional tweakings, right? So here see plt dot axv line. So it basically gives me a vertical line. That's all. So it gives me a vertical line at x equal to 19. X equal to 19 means see the x-axis here, 19. So at x equal to 19, it is giving me a vertical line and I'm putting color as red. And notice the parameter for color here, C. So don't get confused. I told you, multiple methods will be having C, color, you know, it's like that. So here the parameter for color is red. In fact, you know, if you don't want that, you can directly, if you don't want that, you can directly print, you know, it will give a blue color default, but that doesn't look good with the blue. So that's why I'm making it red. Now all of these you can, you know, documentation is one, but GPT also should be able to give you answers. If you're stuck, okay, how to put my color, just give the code and say, hey, I'm using this code, but I'm not getting the color. You get the answer from GPT. Anyway, so what I have plotted for you are the quartiles. So the median is here, right? So to the left of the middle red line, I have 50% of my data. To the right, I have the first red line. Left, I have 25%. Right, I have 75%. So on. Okay. Now I will go back to definition of box plot. So the box plot actually shows quartiles by default. And it's very common in data analysis to use box plots. Let's read these one by one. The box represents the interquartile range, which is the range between the first quartile and third quartile. Basically this 19 to 30. 19 to 30. So the middle 50%. Think of it like this. The box in the box plot is the middle 50%, and then 25 you will have on either end. Okay, so actually let's go and plot the plot so that we understand. So what is the distribution of CT mileage in the data set? Okay, so the command is sns.boxplot, no surprise there. The data is df, x is CTMPG, no surprise there. One line command, right? So let's print. This is what you're gonna get. Okay. This, as you can see, can you see this value? This is 19. You can see the x-axis here is 19, and here you can see 30. So the middle 50% is the box. What is in the middle of the box? Any guesses? Any guess what is this black line in the middle of the box? Put your guess in the chat. Median. Absolutely right, Mahalakshmi. So this 19 is my first quartile Q1. This middle thing, this black line is the second quartile Q2, which is median. And this 30 is my third quartile. So basically 50% of my data is in the box. Outside the box, other 50%. So on the left, 25%. So 25% of my data is here till here. This is called a whisker, by the way. And other 25% is here. Okay, so 25% here, other 25% here. Now, let's go back to the definition. So the box represents the IQR, which is basically Q1 to Q3. Okay, this signifies 50% of the data, and you can also see whether it is in the middle of the box or which side of the box. So it is actually telling where it is skewed. So if it's exactly in between, then you can say that in that middle 50%, less than median and more than median are equal number of data points. Right now, what does it look like? The left side is smaller and the right side is bigger, right? So here you have 50%, here you have 50%. This basically means that for a smaller range, you have the same number of values here, and for a bigger range, you have same number of values here. So supposing total number of values 100, that means in the left rectangle here you have 25 value, in the right also you have 25 value. What is the difference? Difference is these 25 values are more tightly packed and these 25 values are little bit more loosely packed. So this information also you will get from here. Okay, so and why are we getting this information? We want to understand the miles per gallon distribution. So what is this actually? It is nothing but the number of cars of a certain mileage. So basically like more than 30 miles per gallon, I only have 25% of my data set. Okay, more than what is this 19, right? More than 19 miles per gallon, 50% of my data set. And what is the middle 50%? If you ask, more, you can say the typical car in my data set, right? The average car in my data set, or the most common cars in my data set, their mileage is between 19 and 30 miles per gallon. These are the information that you're getting from here. So obviously I'm answering the question, how are MPG values, mile per gallon values, distributed in my data set? Okay, and I hope it makes sense. How am I getting number of cars? It is just the frequency of the data points. Okay, so in your data frame you have all these different mileage values. Let's actually put this concretely, right? City MPG. So each car ID, it's giving me the mileage of that car, isn't it? So for a certain range of mileage, how many cars are there? That's exactly what the box plot is giving me. Okay, so and it's basically kind of the same information as the histogram, isn't it? The histogram is one way of looking at it. The box plot is another way of looking at it. And the box plot is quite common in data analysis because there are some rules that we follow in data analysis. Things like outlier, right? For example, why are these things? What are these two diamonds? So basically, here I'm seeing more than 45. So these whiskers, where are these whiskers coming from? Now if you go because listen to me carefully here, these two diamonds are part of the data set. 100%, they are part of the data set. These are two data points. Okay, they are part of the data set, which means they are included in this 25%. So when I say 25% of my cars are more than 30 miles per gallon, that includes these two diamonds also. But why the diamond is separated from the whiskers? So that is a typical rule in data analysis where we have this rule. So typically anything which is within 1.5 times of the interquartile range. So you extend, so interquartile range means quartile 1 to quartile 3, middle 50%. You expand that 1.5 times, right? So whiskers extend from the box to the minimum and maximum values within a specified range, usually 1.5 times the IQR. Anything outside that range is questionable. We can start calling it an outlier. Okay, again, you will do more of this outlier and everything in more detail in exploratory data analysis, EDA. But Boxplot, applies this rule by default. This interquartile range rule, it applies by default. So for now, just understand that if there are some diamonds, then we need to look at them as questionable entries or outlier entries. In other words, they may make my analysis more difficult. So if I'm trying to represent a group, just because of two outliers, the group characteristic may change, or the representation of the group may be influenced by the outlier unnecessarily. So these are questions we need to handle as data analysts. Now, who are these outliers? That should be easy to find out, right? Let me just, so how would you find out who are these outliers? City MPG greater than 45, that's all. So DF, where DF city MPG greater than 45. What do I want? Car name. What is the feature? I don't know the name of the feature. Is it name? No, error. So I guess it is car name. Yeah. Chevrolet Impala, Honda Civic. No idea why these are outliers. We need to go and check it out. So in fact, you can actually get the row and see why these are outliers. Now, to understand why these are outliers, again, a little bit of research into the domain is required, right? I'm just using car, characteristics. Of course, a lot of us may not know of these characteristics, right? Bore ratio, stroke and all. But somebody from this domain will definitely be interested to know why is this outside. And what do I mean? Why is this outside? It has unexpectedly high city mileage. basically. That's what this plot is telling me. It's telling me that most 50% are between 90 and 30 miles per gallon. These are your normal cars. Then there are some on the lower end, some on the higher end. These are, the tails, you can say 25% here, 25% here. This is also still acceptable. There are a lot of such cars. But then there are some which are just way outside the 1.5 interquartile range, and that's a convention followed. And what do I mean by that, guys? I am not saying that the diamonds are outliers. I'm not saying that. By convention, we can consider them as potential outliers. It is worth looking at. That's all it is trying to say. There is no fixed rule in stone that this is definition of outlier. And whenever you go to your interviews, or all these things are going to happen sooner or later, right? You will be faced with this question: define an outlier. Right? So the answer that should come from you is, there is no eternal, universal, permanently correct mathematical formula for an outlier which I can just apply, close my eyes and say this is correct. No. Potential outliers are those which lie outside the 1.5 interquartile range. They are potential outliers, means they may be. You may choose as a data analyst to keep those data and say, no, this is not outlier, I need it for my data analysis. You have every right to do that. That is a subjective call you need to take. Okay. There are other definitions also. There are other conventions for outlier also, based on standard deviations. Right. So standard deviation is also measure of spread, right? Standard deviation also measure of the variance. So using the standard deviation of a distribution also, I can say more than n number of standard deviation on the right side or left side. It's a potential out. Okay. So there are many conventions on what may be called a potential outlier. You need to check what's going on with the data and decide for your business problem, is this an outlier or not? Very simple example. What I like to give is, suppose I'm thinking something like, suppose I'm HR of, a company, right? And suppose I'm analyzing the salaries of my employees, right, in my company. And I want to know, for example, for some of the more, maybe there's a hiring drive going on, right? And maybe I need to hire salespeople, maybe I need to hire marketing, maybe I need to hire product people, tech people, whatever, right? So, and these are all like, very, very precise functional roles, right? Software developer or data analyst, whatever, these kinds of very precise roles. Definitely the salary is going to be different from CEO. Correct? Definitely these salaries will be different from CEO, CFO. I'm not kidding. It's the fact, right? This analysis is so normal. This is a very typical way of analyzing. Okay. So in that analysis, I will definitely discount the CEO salary. So I'll take the data from the company. I'll create the box plot and I will go check who are my potential outliers. Then I'll see, CEO, CFO. Okay, great. Remove. Then what I have left, that will give me good insight as what should be the salary range when I speak to potential candidates for the very precise functional roles like software developer, data analyst. Making sense? Okay. So again, this is dependent on the business problem. Okay. In a different situation, I may not want to throw the outlier, right? Suppose I'm doing audit, then I will keep them, right? I'll not say outlier. That's part of the auditing and taxation and everything, right? So I'll keep that. So I hope this answers any questions anyone has. Okay. So definitely you will be faced with this question multiple times in this program, outside this program, and it's a subjective call based on the business problem. You should think, is that really something required for my analysis to answer my question? So in the first case, for the HR, I don't need the data. I just need to put quartiles on a proper distribution, and come up with some salary ranges for negotiation with the candidates. So those outliers are disturbing my analysis. In the second case, auditing and other such things when you're doing, I need that. That is only going to tell me what my real distribution looks like, and that is answering another kind of question. Anyway, so I won't go too much into that. You will anyway do these things later. So I hope we are getting a sense of the box plot. Okay, it's basically, so whatever I'm showing here, see these three red lines, that's what you're seeing here. This black line, this black line, this black line. So the box along with the middle line, that is exactly this red color box here, from 19 to 30, this red color box. Okay. And 25% left side, 25% right side. The only difference is it has an inbuilt way of showing potential outliers. So yeah, so statements like this, be careful not to take it literally. Individual points beyond whiskers are considered outliers. By whom? By my HR for the first analysis, yes. By the auditing company for the same analysis, no. Okay. So yeah, don't think Okay, so don't take this one literally. They are considered by whom and for what. Okay? They are potential data points. Potential. See, the word is potential. Anyway, so I hope this box plot thing is becoming clear. Now, another thing you can do with box plot, you can do the same. So here, I think we did a histogram where we split the distribution of the car prices using the car body, right? Similarly, we can do that. So what is the distribution of mileage by car body? And for that, you basically give commands like this. So if you go to your box plot, you can actually, there is a X, there is a Y, there is a hue also. Now, I don't think I'm doing the hue here. That is up to you. So I hope you're understanding this. Histogram and box plot, these are single variable plots by default, right? Either you're analyzing price, or you're analyzing miles per gallon, or you're analyzing some numerical variable. It's a single, as opposed to bar plot, as opposed to scatter plot. Those things are two variables, categorical and then numerical, or numerical. Those are two variables, two dimensional. Think of it that. So when you use the hue parameter there, you are introducing third dimension, isn't it? In histogram, when you use hue or something, you are introducing the second dimension. Okay. Box plot is better than histogram in this reason, because now you have, so I'll just show it to you, right? So now I can, for example, here X equal to car body, right? And Y equal to price. In the previous case, it was directly X equal to MPG, which is why you're getting horizontal. So here, if I say X equal to car body, which is categorical, and Y equal to price, and do the box plot, now you will get vertical plots. Okay. So just for fun, hue equal to door number. Can you see how it has grouped? So there is so much information. So that's my point. So first we'll do without hue. Okay. So first we'll just do two dimensions. One is car body, one is price. So now you have the car body on the x-axis and you have price on the y-axis, and you get individual box plots for all the different types. This is answering even more questions. There are many outliers in sedan in terms of the price of the car. Why are we doing price? Miles per gallon, right? I should change this. City MPG. Anyway, distribution of car, what is that? City mileage. It's okay, just change the thing. I don't know why it was price here, but if the question is mileage, we should answer mileage. So, okay, now there are no outliers. So basically what happened, I think these two have not been considered as outlier the moment they have been put inside one of the categories. So here I did not do the categorical split. There the IQR mathematical formula told me these are potential outliers, these two, Honda Civic and something else, right? The moment I split into categories, now it's not an outlier. Does it make sense, guys, now why I'm saying there is no definition like that of what is outlier? Okay, so you should consider very carefully. Okay, so what happened here? You're basically getting multiple box plots for different car body. Now the same thing for histogram looks like this. Can you add one more dimension to this graph? Answer is no. You cannot add one more dimension to this histogram because X is price, Y is count, and you are stacking using car body. Where you will add one more dimension? Not possible. In the two-dimensional figure, it's not possible to add one more variable. But in box plot, you can do that. That's the advantage. So here the distribution is shown in this box format rather than this histogram format. So here what it is, first of all, what is this telling me? This is telling me that there is very less mileage variation in convertible cars. Look at this. So mileage variation is going, and in fact, let's just talk about the box. So here you have what, 19 to 23 or something. So very, very less mileage variation in convertible cars. Maximum variation I can see in hatchback and sedan. This means there are many models available for many different purposes. That's what I can understand from this. So in the market, there are different types of sedans, one with very high mileage, one with very low mileage, one with typical mileage. So basically it seems that hatchback and sedan are the more commonly, popularly bought or popularly preferred type of car. So the car companies need to provide various choices of various mileage and things like that based on the purpose. Okay. So what this is telling me is that people like hatchback and sedan, right? And because people like hatchback and sedan, but people have different requirements, therefore these hatchback and sedan have much bigger range of mileage values. Okay. So these are the kinds of information you can get from this. Now, as I said, just for fun, we can do this. And if I do that, now you see this is a lot of information. You have the car price on the y-axis, you have the car body on the x-axis, and you are grouping by door number. Okay. So we know that convertible, wagon, these things have only one type of car. So let us see these two, hatchback and sedan. So now using this, you can, this is very beautiful, right? This one is telling me so much. This is giving me so much information. In hatchback, those hatchback cars with two doors are the more prevalent type of car in the market, and therefore they have much higher range of car price. And in fact, this is city mileage, right? So I should change this to city mileage, correct? I think mileage only, yeah, city mileage. So it has way more variation in the mileage offered. So there are many models with different mileage. At the same time, 4-door hatchbacks are very less options. So this could be because of the physics of the car. This could be because of the market demand. I don't know. Why is the mileage offering choice of 4-door hatchback so less? Is it a physics constraint? Is it engineering problem? Or is it a market demand, right? So I hope you can see the more dimensions you're adding to the visualization, the more deeper the analysis gets, right? This is, and the whole idea of data processing, analysis, visualization, and all that is to take you closer and closer to the insights in the data. So if the data is just sitting there and you're not using all these techniques, then maximum what we will do, mean, summation, something we will do, right? Basic. So these are more advanced, taking you closer to the deeper questions, which you couldn't even see the question. Now I can see the question, right? Clearly there is much higher variation even in the box. So if you say, okay, full variation you should not see. Okay, let me only see the middle 50%. Middle 50% itself has much higher variation in hatchback with 2 doors. But hatchback with 4 doors, no. So there is some kind of constraint here, whether it is marketing, market related, physics related, I don't know. But that's where you can go do more subjective research and analysis. Anyway, so I hope this is becoming clear. So in all the plots we have seen from Matplotlib to Seaborn session, this is the only plot where you have seen 3-dimensional visualization. Okay. And I don't mean 3D means 3D, but there are 3 variables here. Right, one is the door number, one is the car body type, one is the city mileage. Great. So I think we can all answer this question now. Please go ahead and answer the quiz. Use a box plot to answer this question. What is the distribution of expenditure split over cuisine? The price variation in Chinese is less. Again, why is that the case? Maybe due to the ingredients, maybe due to the import. I don't know. But that's what we need to investigate. And by the way, the job of a data analyst or a data scientist is not to, take a data and then analyze and say over. No, it's complete back and forth. I have to go ask more questions, get the data I need, again do the analysis, understand things, right? So full report, right? So it's not just made a graph, end of story. No, you have to put everything together. So one question you may want to ask is that, why is the variation in Chinese less? And of course, the whiskers also will tell you something. So if you see here, right, this American, the range of the upper whisker and the lower whisker are actually quite big, right? So there are many cuisine expenditures. So of these prices also, which means a lot of people are spending like $20, $21, $20. It's not that people spending $20, $21 is rare. No, 25% of the data is around this, right? $20, $21. Okay, same way, definitely people are spending $13, $14, $15. This is also there. Where you might say that this is less, think of it in Chinese. For example, in here, the range of the top 25% is what is this? Is around 23. This is around 21. So $2. So this range is $2 on the top 25. And here top 25, clearly it is from 18 to 22, almost $4. Top 25. The range is $4. So the range is very less here. Okay, which means that there may be a limitation in the menu. That is one guess I have. As an analyst, I might say maybe the menu is very limiting here. So everybody is ordering just some combination, which is why range of prices is so less. So then you can think, okay, maybe we want to give a better selection, so on and so forth. All right. Great. Cool. Yeah, I think everyone's doing great. Okay, let's move on to KDE Plot now. So again, I won't spend too much time on this. KDE stands for kernel density estimation. Not to worry about it. It's essentially, so I think last time we discussed, right, something about numerical values and histograms. I think we discussed how can we plot numerical distribution as a continuous. So we think of things like y equal to x square, y equal to log x, right? Our brain is able to understand relations and functions like smooth and continuous numbers, right? Real numbers, not boxes, right? So if I ask you, do you understand y equal to x square? You will say yes. If I say, okay, x is 3, can you tell why? You'll say 9. And if I say, can you imagine a y equal to x square? You'll say yes. So the human brain is actually quite powerful when it comes to, understanding shapes and relations and that kind of thing. But the computer is not powerful at all when it comes to that, right? The computer is thinking in terms of bits. It needs to think in terms of bits. It has a finite. So if you see the processor, it's a finite 0101. There is some memory, there is some pixels. It's all discrete, right? But if I now tell you, imagine a histogram of y equal to x square for 100 bins. Not possible, right? The human brain can't imagine discrete histogram bars and everything. It's not possible. So that's the difference, right? So when we plot on a digital device, we typically do bucketing of numerical variables. It's not possible to convert what we understand to a curve or a graph, smooth graph. So this is where KDE plot comes in. The KDE plot is actually fitting a curve to the histogram. Think of it like that. So let's start with a histogram. Suppose my question is, what is the distribution of horsepower in the data set? Okay. So x equal to horsepower, hist plot. I think this is all very obvious, right? This much is obvious, right? And I hope we all remember subplot. Okay. So when I do plt.subplot 1, 2, 1, that means I think 1 row, 2 columns. Yeah, 1 row, 2 columns. So out of 1 row, 2 columns, my first plot, okay, out of 1 row, 2 columns, my first plot is histogram and everything else is obvious. Okay. Font size, additional parameter, control it and explore it, no problem. And then out of my 1 row, 2 columns, my second plot, that second subplot, I am going to use this thing called KDE plot. Okay. So the command is sns.kde plot. Data is df, x is horsepower, and fill just gives me a nice color. If you want, I'll remove it and show you. The only difference in these two blocks, I hope everybody can see the difference between these two blocks. One is obviously the command hist plot KDE plot. The other thing is my y label. Check it. For my hist plot, I'm putting y label as frequency. Why? We know histogram is nothing but count, isn't it? It is counting. The KDE plot is actually a probability density. It's not a count. Okay. So again, probability density, distribution function, these are things we have studied in school, isn't it? Continuous, discrete, probability, right? Expected value, sigma. We've done all this, correct? We will be doing this in much more detail when you do inferential statistics. Okay. We'll be doing this in way more detail when you do inferential statistics. For now, let's remember what we know from school. Engineering maths, of course. Engineering maths, it was there. Yeah. So we know this, right? We know all these terms. So for a continuous distribution, the y-axis is actually a probability density. It's not a frequency. Okay. So let me go ahead and print this. And tight layout is nothing. It just tries to arrange it so that white spaces are minimized. Sometimes it's a good command. Sometimes it's a bad command. Choose wisely when to use. Typically I use, mostly it works out. Sometimes you may need to add white space. So there are methods to do that. You can explore that later. Okay. So now is it clear what KDE plot is doing? So here, this is my histogram of horsepower. And looks like a majority of my horsepower is, 60 to around 120 horsepower. Okay, these are my majority cars. There are very rare cars, very less, around, what is this? I don't know, 5 cars with 250 plus horsepower. These might be some sports car or something, right? But most of them seem to be in this range. So this is a histogram and the y-axis tells you the count. So KDE plot is nothing but it fits a smooth curve to the histogram shape, basically, right? It's fitting a smooth curve to the shape of the histogram. All right. So, that's exactly what's now this. Why do we need this? The question, the point is that the computer cannot think in terms of relation. So it needs a mathematical formula. And I'm not going to go into the math formula here. It's not necessary for us to understand that in great detail. It is essentially fitting a smooth curve onto these data points. Okay. So this is what you get here. So now you can do different type of analysis. So here in histogram, if I ask you what is the probability that what is the probability that a car has 100 to 120 horsepower? Suppose I ask. For that, you need to make sure that your bar in the histogram goes from 100 to 120. Your bin needs to be 100 to 120. If your bin is 90 to 110 and then 110 to 130, will you get 100 to 120 count? No. So then you can't answer the question, what is the probability that a random car from my data set, it has 100 to 120 horsepower? No, you can't answer that. Now, why do I need this question? In various real life cases, there are limits, there are restrictions. So within those restrictions, if my team leader says, look, minimum 100 mileage, 120 maximum, what's the probability? For that, every time I have to go back and change the bin, correct? Much faster way to control that analysis is continuous distribution. So when you convert to continuous distribution, you can, you have the expected value formula, all of that. Math we will not get into, but I can quickly get the answer from here. I don't need to recreate my plot, recreate my bin, recreate my analysis, not required. Just do this once. I can answer multiple questions using the continuous distribution. So this is the conundrum, by the way. This is the issue that everybody faces. When you deal with numerical variables, histogram is nice, but then when you get into core data analysis, histogram is not nice. Right? It doesn't answer too many real questions. So that's where KDE plot and these kinds of things come in. Okay, so it's just a bit of introduction into discrete to continuous. This is, as I said, you will study in way more detail in inferential. Okay, what's going on here? Yeah, so interestingly enough, if you open the histplot documentation, there is a parameter called KDE. Okay, so when you do the Seaborn, right? Seaborn is making life easy. So there is a parameter called KDE in histplot itself. So if you want to combine the two just to get a sense of the shape, you can say KDE equal to true and only use histplot. So here, as you can see, it is giving you that thing. And fill, by the way, if you remember this fill parameter, that just it fills my graph. It looks a little nicer. Here also, if you want, you can use, but whatever. So that won't look really nice here, obviously. Because you're looking at a line and a histogram. But yeah, to quickly look at the shape, you can actually use KDE equal to true. But notice that y-axis value we will not get. Actually, KDE plot, y-axis should be probability. So here, if you ask the question, now see, this is the way to do. If you ask the question, what is the probability that my car has mileage between 100 and 120? So I would basically draw a line at 100. I will draw a line at 120. And I'll get the area under the curve. I hope everybody remembers now. Integration. Okay. So we'll do this in detail in inferential stats, but essentially the area under this curve between the limits you specified, which is a mathematical formula. So any limit you specify, I can get you the answer. That is the power of continuous distribution when analyzing numerical data. For histogram, not possible. So histogram, you can create 5 bin, 6 bin, 10 bin, little bit of insight, little bit of understanding. But if you really want to answer very precise questions, you need the continuous distribution, KDE plot. Okay. Great. So please answer this quiz. Use a histogram with a KDE to answer this question. What is the distribution of the expenditure values? And again, it's a very simple question. I'm not asking probability and all that. We'll save that for a later time. Sonal, I will take your answer here. KDE equal to true. Perfect. Distribution font size is 12. Okay. Let's check. What is this data actually? QDF. Okay. Very interesting. So this is something that you will learn in much more detail in differential. Does Y label what we should take? Nothing. Honey, again, this is a histogram. You are analyzing one variable. There is no Y variable. Yes.
Sir, I'm having one question. I was trying to do.
Okay. Now, little bit more normal it is getting. As you can see here, it was a bit skewed down. If I just removed a couple of outliers, now it's slightly more bell curve-ish. Anyway, I'm just kind of showing you the things I might do to understand whether it's an outlier or not. Okay. So, yeah, that's a KDE plot. I think we have understood this. Main thing is if you plot it separately using KDE plot, you will get probability. This is the important thing. If you want to quickly check what the shape looks like, you can say KDE equal to true in his plot. It does not give you probability value, but it will give you the shape. Right. Finally, we will be discussing heat maps. Okay. And again, heat map. So heat map is basically a visualization where we want to see. So we want to see, it's like a scatter plot. Now, let me explain. Visually, scatter plot looks nothing like a heat map. We will see that. Scatter plot looks ... something. Heat map looks like a grid of colors. Looks nothing the same. Mathematically, it's very, very similar. Why am I saying that? A scatter plot essentially is telling me the strength of the relationship between two numerical variables, right? So the interest in the scatter plot, what am I really interested in when I do scatter plot? What am I interested in? I'm interested to see how strong are the two numerical variables related. If one increases, does the other increase? If one decreases, does the other increase or decrease? How much is the increase? So these are the things I'm interested when I do scatter plot. Now, there is a way to numerically quantify this, which again, you'll do in more detail in data pre-processing, processing, analysis, those kinds of things next few weeks. But a short introduction here. This is known as the correlation coefficient or Pearson's correlation coefficient. And if I'm not wrong, Pearson's first correlation coefficient. He has given multiple definitions. This correlation coefficient is something that we may have studied in high school or engineering. Somewhere we must have seen correlation or covariance. I hope you remember COV, XY, those kinds of things. We must have seen it somewhere, right? So, and it comes in the same set of topics, right? It is the same topic as distributions, right? Expected value, random variable. Does everybody remember random variable, capital X, right? So then two random variables, X and Y, and then there's this definition of covariance, which is measuring the strength of if X varies positively, does Y vary positively, and how much, right? So that value is called correlation. Okay. Now typically correlation ranges from -1 to 1. Correlation equal to 0 means there is no correlation. Basically, there is no direct or indirect or inverse linear relationship between the two variables if the correlation is 0. If the correlation is far away from 0 and range is -1 to 1. So if the correlation is far away from 0, that is either it is 1 or it is -1 or close, that means that there is a strong linear relationship. It may be negative relationship, it may be positive relationship, right? And let us explore this a little further. So for this, if honestly, if I do df.core, I'll just show you this. Okay, so suppose if I do df.core, it's going to be very difficult to talk about in this session. Okay, there are way too many numerical variables here, and all of these are correlation values, which I don't want to do right now. So we will take a subset of the data set. So we'll take car weight, horsepower, city mileage, highway mileage, price. Okay, so now my data set is basically the cars in my data set, and I have these numerical features. All right, just for the sake of you don't need to do this, by the way. You don't need to do convert d types. As long as your d types are fine, it really shouldn't be a problem. So if I just do .info, I can see int float. So there's no point to do this, but just to be safe, if you want, you can do. In fact, if people don't want to do this, don't do this. It's fine. So the way to get correlation, by the way, I just showed you, is data frame object pandas object dot core. Okay, .corr. So what is my data frame? df numsub. We just I think it's printed here, right? Yeah. So df numsub is basically all my cars, and I have these 5 features: price, highway, city, horse, power, and curb weight. Correlation now calculates the pairwise correlation between all the numerical features in the data set. So curb weight, horsepower, city mpg, highway mpg, all the pairwise values it will calculate. And you just take the data frame and then do .corr, and you can see. Why is the diagonal 1? The diagonal is 1 because you are correlating the same variable with itself. Every variable has to be 100% correlated with itself. In other words, the question is, if my curb weight increased by 1 unit, does my curb weight increase by 1 unit? Obviously, 100% correlation, right? So your same variable correlation will all be 1. This is called autocorrelation, right? Or you can say it's the correlation of x and x. The values you are really interested in are the other values. Okay, so by the way, this is symmetric. Obviously, it is symmetric. So here, if you 0.7507, 0.7507, right? It is symmetric because here the y value is curb weight, here it's horsepower, same thing here it's horsepower, here it's curb weight. So typically, what you're really interested in is the lower half. This lower triangle. Okay, now let's understand the values. So what does it say? Correlation is a statistical measure that quantifies the strength and the direction of a linear relationship between two variables. Okay, it is commonly expressed as the correlation coefficient or Pearson's correlation coefficient, which ranges from -1 to 1. Values closer to 0 indicate weak relationship. Values farther away from 0 indicate strong. Negative means inverse relationship. Positive means direct. Now, why are we studying all this correlation? Because one of the most common metric to visualize using a heat map is the correlation. So this combination is so popular. Okay, df.core, sns.heatmap bracket df.core, right? Most popular utilization of the heat map. Okay, and we'll see why. So basically, this table that you are seeing is now going to be converted into visualization. And I hope this theme is becoming clear. Cross table, count plot. Pivot table, bar plot, correlation table, heat map, right? So understand, data visualization is nothing but another way to see the insights that you are getting numerically. That's all it is. So the question is, can I now visualize this? Before we visualize, look at this value. This is the maximum, I think 0.97, right? Where is it? Where is it? Here. So city MPG and highway MPG are almost perfectly correlated, which means if my car is doing better mileage in city, it will also do better mileage in highway. The least correlated of all of these looks like this one, 68, which is still a strong correlation. It is negative 0.68. In other words, higher mileage, lower price. I think in another cohort I had posed this question, and there were a few car experts. I'm not an expert in cars. I don't know why higher mileage is having lesser price. But one of the answers I got from the other cohort was higher mileage means lower capacity of fuel, therefore smaller price. Okay. So again, I'm just giving you that insight. It's for you guys to dig deeper and find the answer. Anyway, so here is the smallest correlation value I can see. Now, none of my values are zero correlation, because clearly, these things, car weight, horsepower, definitely there will be some correlation between these features. Okay. But this is the smallest I can see, and it is negative. So now the question is, and if you don't like all of these values, just do df.round, and again remember, output is data frame. So format, this is a data frame. What can I do to do the data frame? Anything that I can do with data frame. So dot round, and you get this nice clean value. But anyway, this is what you should be really feeding into the visualization. So now let's look at the hit. Question is there any correlation between numerical variables in the car prices dataset? Answer is obviously yes, right? But will you be presenting this kind of a table in a business report when you're explaining to other team when they don't understand the numbers? No, this is exactly why we have data visualization and storytelling. Right. So for that, the command is sns.heatmap. No surprises there, right? For heat map, it is sns.heatmap, and you just give me the data. So the data is nothing but the correlation matrix. And see, what I'm passing here is a matrix. Okay, it's just x and y. That's all it is. So you can put any numbers. So just think of an NumPy 2D array. That's all. NumPy 2D array with any numbers. Depending on the scale of the numbers, it will produce a heat map. But that is not going to make any sense. You are giving me random numbers. So the use of heat map is where the numbers have meaning. Then only your heat map will have meaning. In this case, the numbers have very important meaning. Okay. So closer to 1 or closer to -1 means strongly correlated numerical features. Closer to 0 means not correlated. In other words, if you change one, don't expect a change in the other. That's what it means if it goes to 0. If it goes to 1 or -1, definitely expect a change in one variable if you change the other. Right? Simple interpretation. So if the numbers have meaning, then your heat map will have meaning. So the input to this is this matrix. The matrix has meaning. Therefore, the heat map is going to be insightful. Okay, anyway, so the data I'm passing here is the matrix of values here, correlation values. Question, does the heat map know that these are correlation values? No. So if anybody is thinking, heat map is only for correlation, that's what I'm trying to explain. No, the heat map doesn't know that the numbers are correlation values. You created those. I can give random number, but that heat map is useless. Anyway, so let me go ahead and run this. Obviously, I did not use any color palette and all that. And, figure size is pretty big. So let me see. Yeah, slightly better. Okay. So, okay. What's going on here? Not the easiest to understand, but okay, black, 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 and here I can see black means most negative, and here I can see bright white or whatever color this is in the diagonal, this is most positive. So strong, in other words, black, so very dark and very bright. These two are strong numbers. Now, obviously, this palette is very bad. Okay, you may want to change, which is why here I'm using a different palette. And now see, parameter name is CMap. Okay, so I've spent a lot of time trying to, is it palette? Is it CMap? Is it C? Is it color map? Is it color palette? So, that is something we all deal with. So don't worry, just try to find out the actual parameters. But I think through these two sessions, I've shown you most of the different parameters, important ones. And later through the program, you will be seeing other parameters. Anyway, so I'm using a different palette here. Okay, this is obviously very bad. Annotation means it will show you the number. In fact, if you see here, I have curb weight, horsepower, city, MPG, highway. It's exactly the same as this table. Nothing else. Curb weight, horsepower, city, MPG, right? That's all it. So this table I'm passing and visualizing. Okay, that's why I have these numerical numerical features here. And annotation, this not equal to true will give me the value inside, nothing else. So here I'm not seeing the value. See, here it is 1.75 or whatever. Those values are not visible here. Okay. So if you say true, it will show the values. Color map I'm going to change, and format. So this formatting is nothing but string format. So if I do fmt equal to 0.2f, this means 2 decimal places floating point number. It's nothing but string format. So this is applied to the annotation. So if I don't do this, you will get full, whatever this is, 0.835305, right? So either you can round it before doing the heat map, or you can format it only while showing the heat map, right? So in this case, you're not disturbing the original value. In that case, you need to create a separate data frame. So just a choice you have to make. I find this easier if you don't want to mess with this stuff, but if you're in a hurry, then you may want to just get the rounded data frame. So I can just take this format.round and I can actually pass it here, no problem, or I can pass it here, and then I don't need to format the output. Anyway, and line width, this is another thing which I think makes the heat map looks better. So right now, if you see, there are no gaps in the boxes. Okay, so the table looks much cleaner because, think psychologically, right? There are gaps. And why do you think the alternate rows are having different colors? So this in the default output of pandas, this is darker, this is lighter, darker, lighter. See the background. It's for us to quickly differentiate. This is row 1, row 2, row 3, row 4, right? It's more of a visual psychology. So same way, and there's enough space between these rows that I can differentiate. Here it's, for example, here, look at this. I can't even see 4 colors. Can anybody see here 4 colors? Definitely not. So so line width is nothing but it puts spaces in these separating lines. So you can see all of these are actually lines. One line here, right? These are the lines that separate the boxes. So, controlling that makes the output look a little better. So with all these changes, and just to remind you, Seaborn single line. In one line, I can do all this. So let me do and see how much better it looks. Let me, 8.4. Let me do 8.6. No, let me do 8.5. Yeah. So now I think it's clearer. Darker red and darker blue means higher correlation. Orangish means slightly lower. So quickly search for the, or you can say lighter blue. So this minus 0.69, this is lighter blue. This 0.75, lighter orange. This one is obviously dark red. And the dark blues are here, 0.8, 0.8, and so on. Okay. So this is one color map. You can try other color maps. I think some that I remember are flare. But again, see, some of these color maps are one-ended, which means it will be dark on one side and bright on another side. Viridis, I think, is it? Yeah, Viridis is also maybe used sometimes. So see, yellow is for stronger, green is for medium, purple is for stronger. But out of all this, I think cool warm somewhat is understandable at least, right? So experiment with different palettes and see what looks good. But anyway, this is exactly what a heat map is. So now, instead of looking at this, I can quickly see here and say, okay, this is my dark blue. This is my dark orange. Okay, price and curve weight, more correlation. This is little light blue, CTMPG and price, negative, but not very strong correlation. Okay? And this is how you use a heat map. And typically, this is used with more numerical features. Then you can quickly see, okay, where are the high correlations, where are the low correlations, things like that. I would urge everyone to try different palettes and see which one you like. Right. One quiz here. Please answer this quiz. Then we'll move to the last part, which is pair plot. Use a heat map to answer the following question. What is the correlation between car weight, engine size, horsepower, price? So 4 features. Kindly answer the quiz. Okay, Sonal. I will take Sonal's command here. Okay, fine. And what insight this gives me? Yeah, this is much better, right? So here, and the reason is here, your correlation values are very small sort of range. What I'm trying to say is a lot of the features are highly correlated either negatively or positively, and very few features are not very correlated. In this, I can see a lot more, difference, and all are positive. Clearly, all are positive. Now, the highest correlation that I can see is 1, which is obvious, right? Medium is around this light blue, light gray, orange, whatever. So I can see, 0.81 and so on. Slightly darker means slightly less. So I don't see any negative correlations in this, but what I can see is that the darker ones are less positively correlated. So what I'm really interested in here is these 2 dark ones. In fact, it is symmetric, so we shouldn't be worried. Just check one diagonal. So horsepower and curb weight. This is having much less correlation than some of the other features. So if you see engine size and curb weight, okay, curb weight means what? Weight of the car. Engine size is size of the engine. So bigger engine, heavier car, okay, 0.85 makes sense. Similarly, engine size and horsepower, I don't know how that works, but I guess larger engine size, better engine. Maybe that produces more horsepower. Power, right? Amount of energy transferred per second. So a larger engine would be able to deliver more power. This is where it's slightly lesser, right? Horsepower and curb weight. So then my question is, why is this not as correlated as the rest? And I wouldn't know, right? Curb weight and horsepower, maybe it's a counterbalancing thing, right? So higher curb weight means higher engine size, okay, and higher engine size means higher horsepower, correct. But bigger car means your power is balanced by the size of the car. You need more power to move the car. So it's having a little less correlation here. Anyway, so this is how you use heat maps. Okay, format, yeah, great. Finally, we'll just look at pair plot. So this is a very it's a plot which I would do as step number 1 if I'm doing numerical to numerical analysis. So what it does is it's also a matrix. Basically, pair plot is also a matrix of plots, and you have features. So all the features are here and all the features are here. Same as heat map, similar to heat map, I should say, right? What it does, it shows me the relationship between, and in fact it is doing exactly the same thing as heat map, by the way. It shows me the relationship between numerical feature A and B in the lower triangle and upper triangle. In diagonal, it will show me histogram. So suppose I just say, my question is study the numerical features, curb weight, horsepower, city mileage, and so on in the prices data set. I would use a pair plot and I will say, just take the subset here, curb weight, horsepower, city mileage. Now, if you just directly do SNS pair plot DF, be ready to wait 1 minute or something. Okay, it will take a lot of time to process and plot, and I'll show you why. Just for this subset, if you do, still plotting. Okay, it took about 10 seconds. I don't know, around 6 to 10 seconds. So this is what you're going to get. I hope it is clear what we are getting here. So curb weight versus curb weight. This is a histogram. So corresponding to that, you have curb weight versus curb weight correlation value. So this is why I said it is kind of similar. Here you have a single value, which is correlation. Here you have the plot itself. So how is curb weight distributed? Next, horsepower. See here, horsepower, distribution of horsepower. City MPG, distribution of city MPG. Highway MPG, distribution of highway MPG. Price, distribution of price. And now all those all those numerical features, you can see they are on the x-axis also. So wherever price intersects with price, you will get histogram of price. Highway MPG, you will get histogram of highway MPG. So diagonal is histogram. What about these other things? Obviously scatter plots. What is the default plot when you want to analyze relationship between two numerical variables? Scatter plot. What is the default plot for one variable? Histogram. So pair plot is just quickly, and maybe I shouldn't use the word quickly, but together it is showing you all the different scatter plots and histograms for your numerical variables. So this way you can start getting some sense of the data. So for example, city MPG in price, very, very interesting negative relation, right? So price is on the y-axis here. So higher price, lower MPG, lower price, higher MPG. Very interesting negative relationship. Now the same thing, the axis will be switched if you go for the other way. So here I'm taking price in the y column and CTMPG on y-axis and CTMPG on the x-axis. I can take price on the x-axis and search for CTMPG on the y-axis. So the axes are just switched, nothing else. X. So here the y is CTMPG and x is price. Here the x is CTMPG and y is price. So just flip the graph. In other words, you don't really need this. You just need the lower triangle again, and maybe the histograms. So this quickly shows what positive, negative, 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 positive, 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 negative, negative. So quickly I can say, okay, which of my features are positively correlated, which of my features are negative correlated with each other. So scatter plots do that. And diagonal tells me not that normal, definitely not normal, somewhat normal, quite normal, almost exponential. So the diagonal tells me the distribution of the features, the numerical features, and the lower or the upper triangle tells me the pairwise relation. Now, isn't this the exact same thing we are doing in heat map? It is the exact same. Here we are representing using the correlation value. Here you are looking at the plot itself. Okay. Let's answer the final quiz, guys. Use a pair plot to answer this. How are the numerical variables in buffet details distributed? And this should not be that hard. It has only 2, I think, right? So let me take Abhishek's answer. Even that takes time to plot. Okay. Negative. Interesting. Okay, that is obvious, right? See, very, very interesting. You can see that expenditure and age, negative correlation. Age, weirdly not normally distributed. Very interesting. More younger people are there. That makes sense, I guess. Older people, I don't think they prefer to jump around from hotels. I think, right? Younger people have the stamina to do that. So, okay, this does make some kind of sense. And expenditure, almost normal. This is what we saw. So this gives you all that information. Gets in one plot. Just remember, it's only for numerical data. And second thing, if you do df dot, so if you just go to if you just do sns.matplotlib, then you need to wait for a while. It may even crash. Be careful, right? It won't crash, but you need to wait for a while. Okay, you will get a humongous plot. It may even say cannot plot. I don't know. Try it. Okay. So let me summarize this. I'll just go ahead and launch the poll. We are already kind of out of time. So while the poll is launched, I'll summarize the session. What we have seen in this learning week is we have introduced ourselves to Python visualization tools, specifically Matplotlib and Seaborn. We understood that Matplotlib is similar to NumPy in the sense that it is very mechanical and abstract in its nature. It is, intelligence and meaning is not something Matplotlib is worried about. Same way NumPy is not worried about. Seaborn is built on top of Matplotlib, just the way Pandas is built on top of NumPy. And Seaborn is something that we can connect with better as humans. It is made for user-friendly data analysis. At the same time, we also studied various kinds of plots, where to use which plot, and we also understood there is no exact one right answer plot. There may be wrong plots, there may be wrong visualizations for certain questions, but there's no such thing as perfectly correct visualization for a certain question. It depends on what you prefer and what kind of information you're trying to share. Okay, and we typically studied things like numerical analysis, categorical numerical analysis, right? Categorical also we did, by the way. Pivot table, bar, yeah, it's also categorical. But when you are talking about cat, that's categorical. Mostly what you're interested in is frequency. So if one category is door number, other category is car type, then you are mostly interested in, okay, 2-door sedan, how many cars? 4-door hatchback, how many cars, right? So in the end, when you analyze, you do have some kind of numerical output, even when you do cat. So it could be the average price of the, the intersection of the two categoricals, things like that. So this is what we saw. We saw numerical, categorical, cat numerical, and we also saw various kinds of plots, and we studied the commands and the the syntax and parameters for Matplotlib and Seaborn.
Thank you for joining me in this journey through data visualization using Python. I hope you found the course engaging and that it helped you build both your skills and your confidence in visualizing data. Remember, the key to mastering data visualization is practice. So keep experimenting with different data sets and tools to sharpen your skills. If you enjoyed the course, don't forget to like, share, and subscribe to stay updated on future content. Also, feel free to drop any questions or feedback in the comments below. I'd love to hear from you.